Well, welcome to MV Tutors. My name is Figa, and today we are doing the prelims, the Gauteng prelims. This is the mathematics paper one, and this paper you actually wrote it yesterday. It was written yesterday. Today is a Saturday. Yesterday was the Friday, so it's the weekend when we're recording this. So probably will be the first ones to take out this memorandum explained in a more digestible way. So without any further ado, let's just get right into it. So it says solve for x. Okay, we can solve for x, no problem, we can do that. So this is 1.1.1, and then we have x is 3, x squared minus 4x is equals to 0. Oh, this one is much more simpler. We just look what's common between the two is x, so take it out and you're left with 3x minus a 4. So then you can say x is therefore equal to 0 because of this one, and then this other one, and I don't want to say equals to, and this other one is just simply gonna be x is equals to 4 divided by 3. That's it. That's just it. No complications there. It's straight and forward. Okay, the next one, which is going to be 1.1.2 is we are given 3x squared minus 4x. Why am I repeating this? This is not what. It's the morning, guys. Please forgive me. It's morning. I just woke up. So it's 3x squared plus 10x minus 4, and that's equals to 0. And they want it to 2 decimals, so probably dealing with a quadratic equation here. So what I like to do then is just write A on top there and B there and C. Okay, and my quadratic equation such that it's minus b plus or minus b squared minus 4ac. You should know it by head, but I think it's in your formula sheet as well. Okay, so minus b, so I'll just put minus and b there. If there's a 10 there, plus or minus square root b, so it's 10 squared minus 4a is 3 and c is minus 4. Cool. So all this is under a square root. I'll divide that by 2 times a, which is 3. Okay, at this point now I should just get a calculator right there. Okay, so let's put our fraction, and then we'll put negative 10 there. Let's start with a plus square root 10 squared minus 4 times 3 times negative 4. And then we'll go downstairs, we'll have 2 times 3. Whoa. 0.36. Okay. That's our first answer. So our x is equals to 0.36. And we need the calculator once again. This time we're just gonna change the we're gonna change that plus into a minus. So we'll delete that plus, put a minus there, and then we get minus 3.69. minus 3.69. So x is equals to minus 3.69. Okay, that's it. We're done with this question. Let's go to the next one now. The next one is 1.1.3. I want to start it down here. Let's go red. 1.1.3, and there we have 15x minus 4 is less than 9x squared. Okay, so that's what we got. Cool. Now this one, the first thing I want to do is put everything in one side. So I'm just going to bring the 9 this side so that it becomes 9x squared plus 15x minus 4 is less than 0. Okay, so we need a graph for this. I prefer the graph method. So because my gradient is negative, I know that it's going to be a set graph, but before we get there, we need to solve for our x values. And for that, once again, we will use the quadratic equation minus b. So I'm not gonna rewrite the quadratic equation, but I am gonna fill it in. Minus b is minus 15 plus or minus the square root of 15 squared minus 4 times a is minus 9, and then c is minus 4. Cool. And all of this divided by 2 times a, which is minus 9. Let's bring out our calculator once again. Let's clear that. Don't need it no more. Okay, so that's what we need right there. Start again. Put a fraction. Minus 15. It's 5. Minus 15. Start with the plus and then square root of 15 squared minus 4 times negative 9 times negative 4. And then we can go downstairs and say 2 times negative 9. So our first answer is 1 over 3. What is that? Okay, let me change it to decimal. 0.03. Okay, so that's it. My first x is equals to 0.03. Is that right? So 1 over 3 is 0.03. Or it's just 0.3. 0.3. Okay, I'll correct that. But while you're here, calculator, let's just go and remove that positive. Put a minus. So that now we're gonna have minus 3.69. It's weird. That's not the answer I'm looking for. That's the previous one. Okay, let's do this again. Sorry, guys. But this is what happens when you make mistakes. You must reevaluate your mistake and then try again. Okay? Squared minus 4 times negative 9 times negative 4. Come downstairs. 2 times negative 9. Okay, there we go. 1.3. Okay. Thank you very much. So this one should have been 0.3 and x is equals to 1.3. So what does this mean for us? It means that if we have a graph, which is typical graph, Let's rub this one and start again. If we have a graph, okay, graph is gonna be like this, and then our graph right here at 0.3, let's say 0.3 is there, and then let's say 1.3 is there. And I know that it's a negative graph. Negative graph is said like that. Okay, so it doesn't matter where the turning point is, it turns somewhere there and then it comes down. All I want is just the x values, right? And then the question, if we look closely there at the question, here we want where this graph is negative, okay, where the y values are negative. So y values are negative here. Okay, the negative here. So the negative between, the graph is negative between infinity, negative infinity. These are the x values to 0.3, and also from 1.3 to positive infinity. You don't like writing it in this method, you can always say x is an element, and then you put negative infinity there to 0.3. That's how you write that one. And this one, same thing, x is an element between 1.3 and a positive infinity, and both with circular brackets. Okay, so that's how you answer that question. Let's move on quickly. The next one is that, okay, let's 1.1.4. It's cool. Let's just do it. So we've got 1.1.4 now. And it says it's the square root of x squared minus 5, okay, is equals to 2 square root of x. Okay, so the first thing we want to do here is get rid of the square roots. So we're gonna square both sides. Gonna square everything, and when we square this, what we get is then x squared minus 5. When we square that, we get 4x, because it's square root squared is just x. And then from there, I'm just gonna bring this side, minus 4x minus 5 is equals to 0. Then all I have to do is factorize this. Now I'm looking for, I could factorize it, I could solve using the quadratic equation, or I could use the method of opening two brackets. All right, now I'm looking for multiples of 5, so I'm gonna go with 5 and 1, and then I want 5 and 1 to give me a negative 4 when I add them. So let's see, 5 has to be negative, so that minus 5 plus 1 gives me minus 4. So then I just come and say x minus 5 and x plus 1, exactly as it's given there. Then I can therefore conclude that x is equals to 5 and x is equals to minus 1. All right, that's it. Cool. Okay, so now we are on question 1.2 now. Let's just do it there. So 1.2, we need more space. So 1.2 says I have 3x minus y and it's squared plus x minus 5 squared equals to 0. And then I say solve x and y. Now, if these are going to be equals to 0, and the only way they can equal to 0 is if this one is positive. Let's say it's positive 1, and then this one must be negative 1. But that gets too complicated. So what's usually better is if this is equals to 0, and that's 0. 0 plus 0 is definitely going to be equals to 0. So that's what we're going to do. We're going to say 3x minus y squared is equals to 0. And then we're going to solve. Okay. So, and then we're going to do the same here, because they both have to be equals to 0. So first of all, I need to get rid of the square. So I square root both sides. Square root of 0 is 0. So I'll have just 3x minus y is equals to 0. And then I can just say y is equals, I just took the y to the other side. Now I'm going to do the same for this one. I'm going to say, I'll take it as it is first. X minus 5 squared is equals to 0. And then I'll solve for x. So square root. And then I have x minus 5 equals to 0. So x is equals to 5. But y is equals to, remember y is equals to 3x. So y is equals to 3 times 5, which is equals to 15. That's it. That's how you do that. So we just solved it quickly. Right. Let us move on now. We are on 1.3. Okay, so where do I want to do 1.3? I want to do it here. Let's go blue. Yeah. So 1.3. It says given this, okay, given x minus 2, if y is equals to x minus 2, show that the given equation can be expressed as that. So I'm not going to worry too much about that. I'm just going to substitute y where x minus 2 is, and it's the subject formula there if you look closely. Okay, so I just want that formula. So it's, first of all, I'm told x minus 2 is equals to minus 4 divided by x minus 2, and then minus 4 there. And then they're saying where I have x minus 2, I must substitute that with y. Okay, so we have an x minus 2 there, so that becomes a y. We have minus 4, and we have x minus 2 there, so that becomes a y as well. And that's minus 4. First of all, I want to get rid of this fraction. I don't like it. So we multiply everything by y. Okay, it's just so that we can get rid of it. Okay, everything must be multiplied by y. So y times y here is y squared is equals to, this one is going to be minus 4, and this one is going to be minus 4y. So if I bring these to the other side of the equation, it becomes y squared plus, I'm going to bring this one first, 4y plus 4. Okay, that's going to be equals to 0. Now let's go check if that's equals to the thing we're given. Exactly. It's exactly the same. There we go. And then 1.3.2 says, hence show that the equation has a real and equal roots. Okay, so when we're talking about real and equal roots, we're now really just talking about the what you call discriminant. Okay, so this is 1.3.2. So the discriminant for it to have real roots must be equals to 0. Okay, and the discriminant is given by the equation b squared minus 4ac. Yes, it comes from the quadratic equation. This part that's under the square root. Okay, it's exactly the same thing. Okay, so here that's gonna be a, it's gonna be 1, that's gonna be b, that's c. So b is 4 squared minus 4a is 1, and then c is 4. This let's solve what this is. So this is 16, 4 squared minus 4 times 1 is 4, and then 4 times 4 is 16. So this gave us 0. Therefore, the roots are real. The roots are real. This was just theory here, that for the roots to be real, the discriminant has to be equals to 0. Okay. And then the last question, calculate the maximum value of s if s is equals to that. Right. Am I going to do this one? Do it right here. C is white. So s is equals to 6 divided by x squared plus 2. This is 1.4. Okay, I got all I need. It's 1.4. So now there's also, you need to know something. For s to have a maximum, that means x squared plus 2 must be minimum. Do the right thing. Let's write minimum correctly. Minimum. So it must be a minimum because it's something you're dividing by. It must be the least value possible. So what's the minimum value of x squared plus 2? This can only, remember, any number squared, whether negative or positive squared, it's going to give you a positive number. So it doesn't matter what number you put here. The least number you can put is 0, because 0 gives you 0, and negative 2 gives you 4, as well as positive 2 gives you 4. So it doesn't matter. So the minimum value then you can put is 2. Therefore, we can say s is a maximum if you are dividing by a minimum value, which is 2. Therefore, s maximum value is 3. Maximum. Okay, that's it. Ladies and gentlemen, like I said, we're the first ones to take these questions out. So thank you so much for tuning in. But in the event there's something that you didn't understand and you want me to tutor you, visit my website, which is www.mvtutors.co.za. You can book a free consultation there, or you can WhatsApp me on 076 312 1107 and you will get me directly. Otherwise, I hope you understood everything we did, and take care. And please don't forget to like and subscribe this video so that other people can get this information. Thank you so much.
Hello everyone and welcome to MB Tutors. I'm Solo and we are still at it with the prelim that you just wrote from the Gauteng province. Okay, so paper 1, question 2, I'll be looking at with you. Okay, sequences and series, and I see that we need to do the quadratic series. Okay, or rather the quadratic sequence. Yeah, we don't really do the series, we do the sequence. Okay, so what is it saying? And let us get down to answering it. All right, so the first 4 terms of a quadratic pattern are 1, 9, 25, 49. Okay, guys, I don't know if you're seeing this, but 1 is actually like 1 squared, and 9, 3 squared, 25 is 5 squared, and 49 is 7 squared. So basically, we're taking the odd numbers and we're squaring them. But anyway, that was just a side note. So it says write down the value of the 5th term. Okay, so what I like doing with quadratic patterns, I want to get the first difference. Okay, so 9 minus 1 is 8, 25 minus 9 is 16, and 49 minus 25, okay, so 9 minus 5 is 4, 24. Okay, and then 16 minus 8 is 8, and 24 minus 16 is 8. Okay, so I know that I would have to have 8 again. Okay, and 24 plus 8, that's actually 32. So the next number should be 49 plus 32. I am not going to attempt to do it in my mind. So let us just add it. So 49 plus 32. But you know how I would know what the next number is? It would have to be 9 squared. But let's see. 49 plus 32, yes, 81, which is 9 squared. Okay, and it is 1 mark. So yeah, you shouldn't really think that much about it. But yeah, either you were to recognize this trend over here, or you would have to calculate it like I did. So it's really up to you. Both ways are applicable. So let me just say 2.1.1, it is actually 81. Okay, and then 2.1.2, show that the nth term of the sequence can be written as 2n minus 1 squared. Okay, so I am expecting that the term formula will have something, because squared, okay, yes, it will have something squared because it's quadratic, but I mean, we can see the trend. We have 1 squared, 3 squared, 5 squared, 7 squared, 9 squared. So yeah, but let's see, guys. So remember, I've shown you this before, but if you're not sure, there's a video that we have posted which touches on the sequences and series, specifically the quadratic pattern. Okay, but basically, if you go and watch it, you'll see where you have why I have this a plus b plus c, and then I have 4a plus 2b plus c. Basically, I'm taking the term general equation, general formula, and I'm substituting 1. When I substitute 1, I get a plus b plus c. When I substitute 2, I get 4a plus 2b plus c. When I substitute 3, I get 9a plus 3b plus c. Okay, if we get the difference between these terms, we are going to get 3a plus b this side, then we're going to get 5a plus b. And if I then take the difference between these two, I'm basically going to get 2a. Okay, and why is that even important? Because I'm going to equate 2a to 8. Then I'm going to equate 3a plus b to 8. Then I'm going to equate a plus b plus c to 1. Okay, yeah, so these numbers there at the end, I'm equating them to each other. You could have taken another route as well. You could have said, again, okay, 2a is equal to 8. Is equal to 8. And then 5a plus b is equal to 24. No, sorry, I took the wrong one. Okay, so it's also 8 there. Okay, so I would have taken this 8, and then 5a plus b, I would have taken 16, and then 9a plus 3b plus c is equal to 25. But I don't want to complicate my life. Why would I do that? I'm just going to take the simple one. Okay, so let us find the equation. Okay, so we're saying 2a is equal to 8. Therefore, a is equal to 4. Okay, then we have 3a plus b is equal to 8. I already know that a is 4. So 3 times 4 is 12. If it goes to the other side, it is negative 12. So 8 minus 12 is minus 4. So that's b. And then finally, I have a plus b plus c is equal to 1. Okay, I have a as 4, b as minus 4, plus c. So those cancel. Look at me. B is minus 4. Okay, so 4 and minus 4 cancel, and then c will be 1. So if I write down my general term formula, I have 4n squared minus 4n plus 1. And remember, guys, they gave us a form in which it should be. Okay, it should be 2n minus 1 squared. So then I need to factorize. Okay. Now I'm going to have 2n this side and 2n so that I can get 4n squared. And I'm going to get 1 and 1 so that I can have 1. Okay, and it has to be a positive here. But here we have a negative, so I'm going to use minus and minus. Therefore, we get 2n minus 1 all squared. Okay, and that is your term formula. Okay, great. We have answered that. And now 2.1.3, they are saying which term of the sequence will be equal to 10,201. So basically taking our equation in the place of, let me just write it again. Okay, this is our term formula. And now they told you what term. Okay, so that term is, they told you the number. Not, we're going to look for the term. We're going to look for n. So we have 10,201, okay, is equal to 2n minus 1 squared. Okay, so I'm going to root both sides so that I can get rid of that squared. Okay, and then I'm going to use my calculator to determine what is actually root 10,201. 101. I'm glad it's a rounded up value. And then this side we have 2n minus 1. Okay, so I'm going to take minus 1 to the other side. I have 102 is equal to 2n. So therefore, n is equal to 102 divided by 2. I think that is 51, but let's check. Ooh-wee. Okay, so that divided by 2. Oh, never mind. I'm doing wrong things. 102 divided by 2, yes, it's 51. Okay, so yes, on term number 51, we're going to get 10,201. Alrighty, so let us go to question 2.2. Now they're saying the first 24 terms of an arithmetic series are 35, 42, 49. I don't know if you see a trend here. For those who used to study their times tables, cram them rather. I used to cram them. So I can see this is the trend for the 7 multiplication tables. Okay, so we have all the way to 196. Okay, so now it says calculate the sum of all the natural numbers from 35 to 196 that are not divisible by 7. Okay, so what are they saying? They're saying we should add 35 plus 36 plus 37 plus 38 plus 39 plus 40 plus 41 plus 40. Okay, now I'm not plussing. Plus 42 plus 43 plus 44 and until we reach to 196. Okay, so these are all the natural numbers from 35 to 196. But they said we should calculate the sum of all the natural numbers, okay? But exclude those that are divisible by 7. So basically, you're going to cancel out 35 and you're going to cancel out 42 and all the other numbers divisible by 7, including 196. So what are we going to do? Okay, guys, there's a strategy. I suggest we calculate the sum of all natural numbers. Okay, that is including the ones that are divisible by 7. Okay, then let's calculate all the sum of the numbers divisible by 7. Okay, then ultimately we're going to say the sum of the numbers not divisible by 7 will be the sum of all natural numbers minus the sum of those that are divisible by 7. Okay, I hope you understood that. So basically we are adding all the numbers from 35 to 196, and then we are getting the sum of those that are divisible by 7, okay? And then at the end, to get the numbers that are natural but not divisible by 7, we're just going to get the difference between the two, okay? Alrighty, let us attempt it. So, do you realize we have the first and the last term? I don't know if there's an equation there. I don't know why my nose is so itchy. So sorry about my constant scratching. Okay, so the sum formula. It's actually not in your formula sheet. Okay, so because we have an arithmetic series, we are basically going to use the sum here, né? But there's a simplified one. If you have the first term and the last term, it would be this n over 2, the first term which is a, and the last term which is l. Okay, you could still use this one, but oh my goodness, it's gonna take a long time. Okay, so if they don't give you this, it doesn't look like they do. Like I said, you can still use this. It's not impossible. You have the first term, you have the difference, okay? So for all natural numbers, the difference would be 1, okay? But for those divisible by 7, the difference would be 7. Yeah, so you can use that equation, but I'm saying this simpler one. So you would have to learn it, okay, if you don't know it. All right, so n over 2, okay? And then we have a plus l. We have the first term, it is 35. And then we have the last term, which is 196. Okay, but what is n? What is n? Okay, so for all the natural numbers, you're going to take, when you want to calculate n, guys, this is important. I'm going to put it in red. When you calculate n, okay, you're going to take your last number, subtract it by the first number, and then add 1. Okay, that is what you have to do. Take the last number, subtract it by the first number, and then add 1. So in this case, we're going to get 196 minus 35 plus 1, and that is 162. Okay, in terms of the numbers for okay, let's just do one thing at a time. Okay, so here then we have 162 divided by 2, we have 35 plus 196, and then its answer is, we have 162 divided by 2, and then 35 plus 196. And our answer is 18711. Okay, 18,711. Okay, and now we are going to get the sum of all the numbers that are divisible by 7. Okay, and the trick there, we need to now get how many terms are actually there. And for that, I'm actually going to go the long route about it. How many marks is this? 5 marks. I'm going to go the long route about it for getting the number of terms. Okay, alrighty. So I'm actually going to use the term formula. Okay, let me just subtract that. Okay, and let me bring this a little bit lower. Okay, so in our term formula, this is what we have. Okay, our first term is 35, and our difference is 7. Look at me writing D again. So our term formula there is 7n minus 7 plus 35. Okay, and so it's 7n and 35 minus 7, that should be 28. Is it? No, that is not 28. Okay, so we have 35 minus 7. Oh, it is 28. I'm doubting myself. Okay, now I need to know the number of terms. Okay, so when I reach 196, how many terms would I have had by then? Okay, so I'm going to substitute 196 and 7n plus 28. So therefore, 7n is equal to, if I say 196 minus 28, so I get 168. We've done this before, ne? 168. And then now, number of terms, 168 divided by 7. Okay, what did I do now? Divided by 7, I have 24. So we have 24 terms. Okay, if you know of a simpler way of doing it, please share with your other fellow matrics and put it in the comment section. Okay, so again, we have n over 2, first term, last term. So n is 24 over 2, first term is 35, last term is 196. So we're going to plug it all in the calculator. And we're going to have 24 over 2, that's just 12. And then 35 plus 196. Okay, so we have 2772. All right, so now we are finally getting to answering our question. The sum of all the natural numbers from 35 to 196 that are not divisible by 7. So sum of all the natural numbers that are not divisible by 7 is actually equal to 18,711 minus 2772. Okay, sorry about that. Okay, and then yeah, so we have 18,711 minus 2772. It's 15,939. We're done with question 2. So yeah, I hope you guys enjoyed watching that, and I hope you got it correct in the exam. Okay, and if you didn't, this is your opportunity to see where you went wrong and practice again, so that next time if they ever ask something like this, you are better prepared. Okay, it's not the first time I'm actually seeing a question like this, so if you have practiced enough past papers, you would have at least come across something like this. Okay, thank you for tuning in. Please don't forget to like our videos and subscribe to our channel. All right, bye. Hello everyone, and welcome back to MB Tutors. I'm Tsulu, and I'll be looking at question 3 with you guys, still added with the prelim paper, the Gauteng one to be precise. Okay, so we have a geometric series. Okay, yeah, so it is 5, and inside the brackets 3x plus 1. So we see each time the brackets, the exponent just keeps increasing by 1. So we have to the power 1, to the power 2, then to the power 3. Okay, so now they're saying, for which values of x will the series converge? Okay, guys, what do we know about converging series? We know that the common ratio, which is r, okay, the common ratio has to be in between -1 and 1. I normally say that the common ratio has to be like a fraction, 1 over something, for the series to converge, because the numbers have to keep getting less and less. Okay, so when it converge, I normally illustrate it like this. They start out big, and then they come out to be small, and then finally they, at the sum to infinity, if you add it, you get your term. Okay, but yeah. Anyway, so this series is converging, so we need to get the common ratio, okay, and make sure that it is in between -1 and 1. Okay, so what is our common ratio? So we have 5. Okay, we have 5, 3x minus 1 plus 5, or rather, let me just put that, 5, 3x minus, why am I saying minus? It's plus. It's plus 1. Okay. Now that is a major disability if you can't copy exactly what you are given. Okay, I sometimes make that mistake. So for you to get the common ratio, you need to take the second term, okay, and divide it by the first term. And that will equal to the third term divided by the second term. So if we divide the second term by the first term, the 5's will cancel, one of these will cancel, and then you're left with 3x plus 1. Again, if you take the third term and divide it by the second term, the 5's will cancel, and two of these 3x plus 1 will cancel, you'll be left with one of it. 3x plus 1. So that is your common ratio. So now they said we should find the values of x where this series will converge. And guys, I just wanted to show you that I think you do have the formula there for yes. So where you have converging series, this is what you will use. Okay, yeah, so I hope you got it. So yes, r has to be in between -1 and 1, and this is the sum to infinity, a over 1 minus r. But anyway, we are now solving for x. Okay, so we know that r has to be in between -1 and 1, and we have seen that r is 3x plus 1. Okay, if I take 1 to both sides, it's going to be -1, so here I'm left with 0. And -1 is -2. And then if we just divide everything by by 3, so that we have x, we have -2 over 3, and we have 0, and that is our answer. Okay, x is in between -2 over 3 and 0. Okay, 3.1.2. So they say, calculate the sum to infinity of the series if x is equal to -1 over 6. So we did say the sum to infinity is equal to a over 1 minus r. Okay, let me just make sure. Is it really 1 minus r? Yes, it is. Okay, so we have a, don't we? Yes, so a is actually the first term, which was 5. 3 times x, we know that x now is -1 over 6 plus 1. Okay, so 3 times -1 over 6 is going to be -1/2 plus 1, and then 1 minus 1/2 is 1/2, and 1/2 times 5 is 2.5, but I'll just write 5 over 2. So that is a. And then what is r? R, we said that it is 3x plus 1. So 3 times x plus 1. So again, we have negative a half plus 1, which is a half. Okay, so now we can solve. This was just working out on the side. Okay, now we can solve. A, we said is 5 over 2, and 1 minus a half, which is still a half. Okay, so we have 5 over 2 divided by 1 over 2, which is the same as 5 over 2 times 2 over 1, and then our answer is 5. Okay, then now 3.2. Okay, so they say determine the smallest value of k for which, hey, a lot of students sometimes cry about the sigma notation. It's actually not that bad, guys. I'll show you how to tackle it. Okay, so we have the sigma notation. We go from 1 up until k, and you can see there 2 to the power p minus 4. It's actually a geometric sequence. Okay, yes, and that has to be bigger than 30. So what are they saying? In essence, okay, remember sigma, let me just say, sigma is like saying the sum of. So they're saying the sum of a geometric series or sequence has to be bigger than 30. Okay, so let's just go get the formula for the sum of a geometric sequence series there. So we have a r to the power n minus 1 all over r minus 1. And we're saying that sum has to be bigger than 30. Okay, so now, yeah. Okay, so what do we have there on the sigma notation? And we're looking for the smallest value of k. So what I'm going to do, what I normally tell my students, we're going to get the first term, okay? And we have our formula there. Instead of putting p, we're going to put 1 minus 4. So that's going to be 2 to the power minus 3. You know, it's the same as saying 1 over 8. And then we get our second term. We're going to substitute 2 in the place of p, which is then 2 to the power minus 2. That's the same as a quarter. And then we get 3, okay, our term 3. So we're going to put 3 in terms instead of p. And we're going to get 2 to the power minus 1, which is the same as a half. So basically, in my sequence, we have 1 over 8, 1 over 4, and 1 over 2. So I can then see that my common ratio, I keep multiplying by 2. Because 1 over 8 times 2 is going to be 1 over 4. 1 over 4 times 2 is going to be 1 over 2. So that is my common ratio. And that is why I get the first, second, and third term. So that I can determine what my common ratio is. Okay? Because you can see in your sum formula, you need to get R. Okay, so we have R. R is 2. Okay, and our first term, we have worked it out. It's actually 1 over 8. Okay, so we have A. And now, how do we get N? So like I said, guys, no, actually I haven't said it. Or did I? In question 2, sorry, if you watch the video for question 2, you'll see how we actually calculate N. Okay, so I'm going to put it again in red. If you want to calculate N, you take your last term, which is K, subtract by your first term, which is 1. Okay, so it went from 1 all the way to k. So k minus 1, and you always add 1. So basically number of terms, that is k. Okay, so we have everything that we need. We're just going to copy the sum and solve it. We're going to solve for k. Okay. All right. So now we have a, right? A is 1 over 8. okay? And then we have r, which is 2. We have n, which is k, okay? And then again, we have r, it's 2 minus 1. And all of this has to be bigger than 30. That is what they told us, okay? So 2 minus 1 is going to be 1. Okay, so now I have 2 to the power k minus 1. And then I'm taking 1 over 8 to the other side. So it's actually 30 times 8. Okay, what's 3 times 8 is 24. So this should be 240. Okay, now if I take 1 to the other side, I'm going to have 241. Okay, now we are solving for k. All right, it would be nice if 241 could be written with a base 2, but that is not the case. We're going to have to use logs. Okay, so how are we going to do this? All right. Yeah, so I'm going to take, so k is the power, right? So k is going to be this side, okay? And I have log 2, 2, 4, 1. Okay, I hope I did it there correctly. Okay, so let us solve it. Okay, so log base 2, 2, 4, 1. Okay, what is my calculator doing? It's failing me. Okay, let's try again. So I have log 2 and I have 2, 4, 1. Why is it giving me the answer like this? Okay, yay. Something is happening. So I have 7,91. Okay, so k is actually smaller than 7,91. Okay, but they said we should solve for k. So the smallest value then for k, it would be equal to 8. Okay, the smallest value would be equal to 8. So it's just pretty much rounding up the 7,91. Remember that k can't really be a decimal or cannot be a fraction because, oh yes, they did say k is an integer. Okay, so yeah, where k is an element of integers. Okay, so yeah. Actually, no, I made an error there. Okay, k is equal to 8. If it was smaller, then k would have to be equal to 7. Okay, so yeah, I hope I didn't lose you there. Whenever you have sigma notation, first thing, guys, get the first 3 terms so that you can calculate what your common ratio is if you have a geometric series. Get, D if you have arithmetic series. You also want to get your first term, okay, so that you can use your sum formula to actually get the sum that they want. Okay, so we are done with question 3. Again, guys, just a reminder, please like our videos and subscribe to our channel. All right, I hope you learned something, and yeah, bye. Hello everyone, and welcome to MV Tutors. I'm Solo, and I'll be looking at question 4 with you from the paper 1 prelim in the Gauteng province that was written recently. Okay, so we have a hyperbola. Okay, some would say hyperbola. I don't know what do you pronounce it as, but I prefer hyperbola. So we are given a hyperbola, and it is, so you need to ask yourself, whenever you get a graph, we know with parabolas, you have a happy face, which is a positive, and a sad face, which is a negative. We know with straight line graphs, if the gradient, it increases from left to right, we know it's a positive one. If from left to right, it decreases, we know it's a negative graph. So with a hyperbola, how do you know? Well, basically, if, I'm just gonna do a basic hyperbola here. if your hyperbola, the basic one being y is equal to a over x, if it's a positive one, okay, from the left to the right, if it moves up from the left to the right, then it's a positive one, okay? But if it goes from the left to the right and it goes down, then you know you have a negative hyperbola. Okay, so in this case, guys, we have a, which is 2. It's actually positive. Okay, so we are expecting our hyperbola to be in quadrants 3 and 1. That is our expectation going into this question. Okay, and then again, we have the that plus 1, we have a horizontal shift, so it has been shifted 1 unit to the left. If it's plus 1, shifted 1 unit to the left. Okay, horizontal shifting is like opposite. Okay, so if it's plus 1, it's shifted 1 unit to the left. And minus 3, well, it just means it has been shifted 3 units down. So that one is just basic, it's straightforward. Okay, and then what else? Yeah, let's read the question. I'm already now doing things without reading the question. So it says, write down the coordinates of the y-intercept of f. Okay, so after we calculate y, the y-intercept, remember, you must put it in coordinate form. That's what they asked. They didn't ask for the y value, they asked for the coordinates. So we know that the y-intercept, that is where x is 0. So I'm going to say y is equal to 2 over 0 plus 1 minus 3. So that's basically 2 minus 3, which is minus 1. Therefore, my graph will cross the y-axis at negative 1. And then 4.1.2, they want to calculate the coordinates of the x-intercept. Okay, question 1, they said write down. I had to calculate, okay? They're just assuming you can look at it and be like, this is the answer. But yeah, here they say calculate. I'm just going to put it on the side because we're pretty much calculating similar things. So x-intercept, that is where y is equal to 0. So I have 0 here, 2 over x plus 1 minus 3. So I'm going to take 3 to the other side, and I have 2 over x plus 1. And then I'm going to take x plus 1 to the other side, and then I'm left with 2. So 3x plus 3 is equal to 2. 3x is equal to negative 1. And now x is negative a third. And that x-intercept would be coordinate is, yeah, basically that. Okay, now they say sketch the graph in your answer book. Okay, another thing, in our equation, we should actually state, okay, so we're gonna, as we sketch, just be aware of the asymptotes. So what are the asymptotes? Asymptotes are those imaginary lines that the graph tends to touch but doesn't really touch it. So asymptotes. So for the x, okay, remember x plus 1 is equal to 0. So our asymptote is actually negative 1 and y is equal to negative 3. So we just need to be aware of all of that as we sketch our graph. Okay, so if you look at our values, they're mostly on the negative side, right? Okay, so I'm just gonna see, I have mainly negative values, so maybe I should be drawing this more towards the side rather. Okay, and then maybe more like that. Okay, so here we have our y-axis and then we have our x-axis. So we know our asymptotes is minus 1. So I'm just going to say that's minus 1, minus 1, minus 2, minus 3. Okay, I'm going to attempt to do the asymptotes now. So we know that we can't be touching So it's like a dotted line. Ooh. All right, we will do with whatever. And then for -3, let me try to draw that. Okay, we tried. Okay, I'm gonna draw the graph in a different color. Let's go for black. So we know that our graph, the x and y intercepts. So the x-intercept is -1/3. So I'm gonna assume it's somewhere there. -1/3. And then it is, the y-intercept is -1. Okay. So basically our graph will then look something like, okay, it'll go that side. Remember I said it's a positive graph because A is positive, so it's gonna go from left to right. It's gonna increase like that. Okay, so it's going to be on quadrant 3 and 4. Sorry, quadrant 3 and 1. Okay, and then the other side. Okay, so that's basically our graph. We have our x and y intercepts. Okay, they said we should clearly show the asymptotes and the intercepts. So I'm just gonna put there, we have -1/3 and 0. Then we have -1. Then we have 0 and -1. And then our asymptotes, we have x is equal to -1, and then we have y is equal to -3. And that is our graph, guys. Yeah, in the exam, you have a proper sheet that you can draw with, rather. So it's much better. Okay. We have drawn it. Okay, so now 4.1.4. So it says one of the axes of symmetry of f is a decreasing function. Okay, you do know with a hyperbola, you have axes of symmetry. Okay, I'm going to indicate that with red. All right, so basically you have one that comes like this. Okay, and then you have another one that comes up like that. Okay, yay. Whew. At least it worked out. And then which one is negative and which one is positive? Obviously, the one that slopes downwards like that, okay, from left to right, it goes down. It has a negative gradient. So m is negative. The gradients, guys, okay, so the equations of the axis of symmetry of a hyperbola, the gradients, if it's a decreasing function, it is -1, okay, always. If it's an increasing function, the gradient is +1. Please don't forget it, okay? But here, what they are asking for the decreasing one, okay? They don't want to know both of them. They just want to know the decreasing one, okay? So now they're saying we should determine the equation of the axis of symmetry. Okay, guys, when you determine an equation of a straight line, I don't know how you do it, but for me, I require two things. I require the gradient, and I already said it's -1, and I require a point, okay? The nice thing about a hyperbola is where your asymptotes cross, that is where your axis of symmetry also crosses. So the point there, the point I'm going to take or refer to is the intersection of the asymptotes. So I know that x is -1 and I know that y is -3. So I have my gradient, I have my point, I can get the equation using the equation. I can get the equation of the axis of symmetry using a straight line equation formula, which is y is equal to mx plus c. So in the place of y, I put the -3. In the place of m, I have -1. In the place of x, I also have -1. And then I'm going to determine what c is. So I have -3, and then -1 times -1 is +1. If I take +1 to the other side, it's negative. Okay, so then ultimately c is -4. And then when I write down my equation, it is going to be negative x, negative 4. Okay, so basically, this line is crossing the y-axis at negative 4. And it makes sense, okay? And it should also cross it at x is equal to negative 4. Like, yeah, determine the equation of the axis of symmetry. That's it. They didn't say anything about drawing it, ne? But yeah, the y-intercept should be negative 4 because the y-intercept is c. But if I wanted to get the x-intercept, I'll make y 0, take x to the other side, and it will also be minus 4. Okay, they didn't ask for this information, but I'm just giving it to you. Mahala nje, okay? So, yeah. And then we are done with question 4. This is actually a nice question. I think basically, yeah, I think it was nice because I had to draw. I like drawing. So, yeah, I hope you enjoyed and I hope you learned something. Please remember to like our videos and subscribe to our channel. Please go over this, especially if you know that you struggled with question 4. Try to understand it, okay? And if you need a tutor, if you don't understand, you can always visit our website at www.mvtutors.co.za. And yeah, we can see what we can do. Okay, bye. All right, hello everyone, and welcome to MV Tutors. So I thought I was done with question 4 until I turned I scrolled up and then I saw I am not done. Okay, so this is a continuation of question 4. Alrighty, so 4.2, we have a function defined by t. Okay, so that is log a x. Okay, so basically, if you want to know, just for interest's sake, this is a log, right? It's a log graph. So meaning before that, there was an original graph, okay? If you want to know how the original graph looked, so you have your axis of symmetry there, y is equal to x, and your graph pretty much has to be symmetrical about that. So your original graph actually would look like something like this. Trying to see how I can actually draw it nicely. Okay. So it would be we'll start like that. Okay. It would do something like that. Yeah. Okay, yes. Yeah, it would do something like that. So if that's t, that would be its inverse. Okay, cool. And you know that, sorry, now I'm giving too much information, but you know that the original graph, normally, this graph would be like 1 over a to the power x, whereas your original graph, is like something like this, where this would be a to the power x. Anyway, that's just an extra information that we don't even know we need. But let's answer. So we have been given point C, okay, and point A. So they tell us C is the x-intercept and point A, which is 5 and minus 1 on the graph T. So what do they want from us? So they want us to write down the coordinates of C. Okay, guys, if you want to write down the coordinates of C, actually what I was doing was not useless. It's actually good, and I'll show you why. With your graph here, the original one, where you have a is equal to the power x, it always passes the point 1, okay? And then you have the inverse of it, which is also written as a to the power minus x. It also passes 1. So basically, we are expecting C to also be at 1. And you can see it's only 1 mark that they have there, okay? So your answer, the coordinates, is going to be 1 and 0, okay? You don't have to think too much about it. It's just by knowing the graph that you have and its properties. All right, now they say write down the range of graph T. The range are all the y values. Okay, so y is an element of, do you see that it can go on and on and on? Okay, so it goes from negative infinity. And also, if we look at it on the positive side, it can also go on and on. Okay, now when we have infinity, you do not put square brackets, it is always round brackets. Okay, and I prefer that you start from the smallest value to the largest value, so negative infinity to positive infinity. Okay, and now 4.2.3, calculate the value of a. All right, so I'm just gonna say, instead of writing t, function of t, I'm just gonna say y, and then I have log ax. So I'm gonna put this in a form that I am used to. Okay, I'm gonna take it to its, before we logged it, okay, take it back. So x is equal to a to the power y. All right, and then they gave us a point a, remember? And that point a is 5 and minus 1. So I'm going to substitute 5 where x is, and I'm going to substitute minus 1 where y is. Okay, so basically I have 1 over a, which is the same as a to the power minus 1, is equal to 5. Okay, so a then will be 1 over 5, or you could say 5 to the power minus 1. Okay, because what you could have done here, once you are at 5 is equal to a minus 1, to get rid of the minus 1, you would have took it to the power minus 1. So then you have 5 to the power minus 1, and you have a. Okay, different ways to write it, but yeah, this is the answer. Okay, 4.2.4. The graph of h is equal to tx is transformed by a reflection of t about, oh, so yay, I already drew it for you guys. So it is transformed by a reflection of t about the line y is equal to x. Okay, so basically, that one, this is actually h, the one that we drew here. This is h, and the one that we have here, right, is t. Okay. And this one is just my own one. I'll call it S something. All right. So determine the equation of h in the form of. So basically, that would be y is equal to 1 over 5 to the power x. Okay. Yeah, I'm just looking here. I actually shouldn't have used a. I shouldn't have used a because we have a there. Yeah, so just look at it as b, just in general. But yeah, anyway, it's done. Okay. Yeah, so basically, if I were to redraw it, if maybe you didn't understand properly. Okay, this is not such a nice graph, but you have that graph, right? And again, we have our y is equal to x. So it has to be like symmetrical. Okay, so basically that is h. Okay, and that is t. All right. And if t, the function for t, if t is actually y is equal to log, remember a, we said it's 1 over 5. So we have log 1 over 5 x. Then we know that this one, h, is equal to y 1 over 5 to the power x. Okay. Yeah. Okay. But yeah, that's what we just did there. I think let's not waste any more time. Now we have 4.2.5. Okay. So write down the domain of h. Okay, so if we look at h, the domain is all the x values. Okay, so do you see on the negative x side, this graph can go on and on and on. Okay, and also on the positive side, it can go on and on and on. So therefore, x is an element of negative infinity to positive infinity. Okay, And then 4.2.6, they say write down the equation of the asymptote of h. Okay, so our normal graph, okay, the one that looks like this, the original one, okay, where you have y is equal to, I'm just going to say b to the power x, and this one would actually be y is equal to 1 over b x, and yeah, that would be, yeah, anyway, the original one that would have is y is equal to bx, right? And if you're going to get the asymptote, so this graph, it tries by all means to touch the x-axis, but it can't, and it won't, it never will. So therefore, its equation of the asymptote is actually y is equal to 0. Even h, as we have it, okay, it's just pretty much the invert, or it's h is like this original graph reflected about the y-axis. It also tries to touch the x-axis, but it can't, and it never will. So its asymptote is actually y is equal to 0. If you're going to get the asymptote of c, it tries by all means to touch the y-axis, but it won't. So its equation is actually x is equal to 0. But they asked us about h. So the equation of the asymptote is actually y is equal to 0. And then we are officially done with question 4. Okay? So yeah, thank you guys for tuning in. Don't forget to like our videos and subscribe to our channel. I'll see you next in question 5. Hello everyone and welcome to MB Tutors. I'm Tsolo and I'll be looking at question 5 with you guys. We're still going at it. Prelim things. Okay, this is the Gauteng paper, okay. So yeah, given that the function f is equal to negative ax squared plus bx plus 6. Okay, so I see we have a negative. So I can see this is a sad face parabola. Again, some people say parabola, others say parabola, and others just stick to quadratic function. Okay, so we have a negative, a sad face parabola. All right, so now they say the gradient of the tangent to the graph of f at the point -1, at the point -1 and 7 over 2 is actually 3. So I don't know. I don't know what this graph is, but it's a positive gradient, okay? So if it's a positive gradient, it must lie somewhere this side. So it could be somewhere here, could be somewhere there, but we know that the gradient is actually 3, so m is equal to 3. Either way, it cannot be this side, guys. This one is a negative gradient, so yeah. So it's a positive gradient. And then what are they saying? Show that a is a half and b is 2. Okay. So what I'm going to do, I have a point, right? So let's just say this was the gradient. And the point there is -1 and 7 over 2. Okay, so I have an equation, guys. I'm going to just write it this way. Y is equal to negative ax squared plus bx plus c. I'm going to substitute that point that I know. So the y value is 7 over 2 or 3.5, and x is -1. Okay, so I'm going to simplify it. So I have, okay, let me just stick to the fraction. 7 over 2, and then I have negative a, negative b, plus 6. Okay, so I'm going to take a and b to the other side. A plus b is equal to 6 minus 7 over 2. Okay, I'm really going to simplify it. So 7 over 2 is 3.5. So 6 minus 3.5 is actually 2.5. So I have my first equation. Because I have two unknowns, I need to have two equations. Okay, the other thing that I know, this is where we use calculus theory. Remember, maths is cumulative. You can't forget one thing, and they could ask anything at any time. So you can't say, No, but these are functions. Why they're asking us calculus things? You must just know all the time and apply. Be ready in and out of season. Okay, so we know that if I were to get the first derivative of f, okay, that is actually equal to the gradient. Okay, so what is the first derivative? Remember our equation is negative ax squared plus bx plus 6. Okay, so we're just gonna take down the 2. So I have negative 2ax. Okay, and then I have plus b, and then the 6 actually just falls away. And our gradient, they told us that the gradient is 3. Okay, so again, I have that point minus 1 and 7 over 2. So I'm just going to substitute minus 1 at x. Okay, minus 2a minus 1 plus b is equal to 3. So I have 2a plus b is equal to 3, and that is my second equation. Now I'm going to get the difference between the second. So I'm going to take the second equation and I'm going to subtract the first equation. So I have 2a plus b is equal to 3 minus a plus b, 2.5. And then my answer is going to be a. The b's cancel out. And 3 minus 2.5 is actually 0.5. So a indeed is a half, like they said we should prove. Then I'm going to take a and substitute it in equation 1. So equation 1 was a plus b is 2.5. A, we found that it's 0.5 plus b 2.5. So b is 2.5 minus 0.5, which is 2. And we have shown it. So actually when you write down the equation of f, it's actually negative a half x squared plus 2x plus 6. Okay, and then 5.2 says calculate the x-intercepts of f. Okay, so the x-intercept, that is where y is equal to 0. So 0 is equal to negative half x squared plus 2x plus 6. Okay, I am going to remove the negative a half. Okay, if I take negative a half out, I'm left with x squared. Then I have a negative 4x because negative 4 times negative a half is positive 2. Then I have negative 12 because negative 12 times negative half will give me 6. And then that half falls away. So I have x squared minus 4x minus 12. Here you can use the quadratic formula, or you can just go straight and factorize. Okay, we need to look at the factors of 12 that will give you 4. Remember, you have 1 and 12, you have 2 and 6, you have 3 and 4. And if I look at all of this, 2 and 6 will give me 4. Okay, so I have x, 2, 6, and it's a negative 4, right? So it has to be negative 6 plus 2 will give me negative 4, and negative 6 times 2 will give me negative 12. So x is equal to negative 2, or x is equal to 6. So if I look at the x-intercepts, I have negative 2 and 0, and I also have 6 and 0. Okay, and then, wow, the x-intercepts, that was just 2 marks. That was a lot that we did there for 2 marks. All right, 5.3. Calculate the coordinates of the turning point of f. Okay, so there's a formula. I don't think they give it to you in the formula sheet. If you want the turning point, okay, that's just for the x coordinate. Okay, it's actually equal to negative b over 2a. Okay, so if I look at my equation, b will be 2 and a will be negative a half. Okay, so negative 2 over 2 times negative a half. Okay, and then what we have is 2 times negative a half is 1, or negative 1. Negative 2 divided by negative 1, I get positive 2. So my turning point should be somewhere, I drew the, yeah. So my x value should be 2. Okay, but now I need to get the y value. Okay, and if to get the y value, you need to substitute this 2 into the equation. So y is equal to negative half times 2 squared plus 2 times 2, right? That's the equation. Plus 2 and then plus 6. Okay, so I have 4. 2 squared is 4 times negative a half is minus 2 plus 4 plus 6. So 4 plus 6 is 10, minus 2 is 8. So therefore our turning point is 2 and 8. Okay. Another way of doing it, you could actually complete the square such that you have your equation like this. X minus P plus, and then you know that P and Q are actually your turning point. But I'm not going to do that. That is very time consuming. Okay, and then 5.4. Now we're sketching the graph. Okay, and we are going to include intercepts and all. So I'm just going to I'm just going to remind myself of the intercepts. Okay, so we calculated x minus 2 and 6. Okay, so that's minus 2. Okay, and then our turning point was at 2. Okay, so we have that dotted line there. So it's at 2 and 8, right? So I'm just going to say that's 8. So that is our turning point. And what else? Yeah, turning point and, oh, the y-intercept. So the y-intercept, we got, oh, we didn't calculate it. Oh, we don't need to calculate it. The y-intercept is 6. Okay, so from the graph, if you make x 0, you're going to pass 6. Okay, so now we can sketch our graph. I'm going to use black. So it's going to do something like that. Okay, and on the other side, it's going to do something like that. Okay, and that is our graph. Okay, f of x. Cool. Now, what are we doing next? So, 5, 5. Use the graph to determine the values of x for which the function f of x is bigger than 6. Or rather, I would say where the y values of x, the y values of f of x are bigger than 6. So let's see. Where are the y values bigger than 6? Do you see that the y values are bigger than 6 here? And then until they reach the other side. So up until there. Okay. So now, how do you know? Yeah, so that's where they're bigger than 6. So we need to determine what this value is of x. Okay. And how are we going to determine that? Okay. So they said the x values. Okay. So we already know that x is bigger because that's where 0 is. You know where 6 is? So x is 0 there. Okay. And it mustn't be included. Okay. So it starts from 0 and then it ends somewhere else. So how do we know? Actually, my graph is not to scale. So let me just remove this. Okay. Here's how we know the spacing in between. Okay, do you see from 6 to the turning point, it's actually 2 units. Okay, so therefore it means from the turning point to the other side, because the parabola is symmetric about its turning point. Okay, so we have 2 units there. And also this side, we're going to have 2 units. Okay, meaning here from 2 plus 2, we have 4. So actually our thing is supposed turning point, yeah, the way I drew the graph. Okay, so yeah, I'm trying to be a perfectionist. So the graph must be something like that, right? And we're gonna get there. Okay, so it's 4. All right, but anyway, what matters is you know the answer. So x is in between 0 and 4. And we're not using this, guys. They didn't say f of x bigger and equal to 6. They just said bigger than 6. So we cannot include the equal signs there. Okay, and then 5.6, sketch the graph of g. Okay, so g is minus x minus 1 on the same set of axes as the graph of f in question 5.4. Okay, before I sketch it, I need to know what the x and y intercepts are. Okay, so the x-intercept, where y is equal to 0, I'm going to get 0 is equal to minus x minus 1, therefore x is equal to minus 1. And if I get the y-intercept, I know that x is equal to 0, so y is equal to minus 1. So I know I'm going to have, let me choose a different color. I'm going to choose red. Obviously, you're going to use the same color in the exam. You can't be using red. So x is minus 1 and y is minus 1. So I'm just going to do that. And then we need to draw the graph. Okay, let me make it somewhere a bit there. Not that it makes much of a difference. Whew, let's see how we're going to sketch this. Okay, so... okay, this is how the graph is going to be. All right, and that is what? G. Okay. What I'm going to do, I'm going to extend F a little bit, just so that I see where they actually intersect. Not that it's really fully accurate, but yeah, just to see. Okay, so we've drawn the graph. Okay, clearly indicate all intercepts with the x's, with the axes. Okay, so we have minus 1 there and we have minus 1 here. Okay, and with our x-intercepts, I should have actually written them in coordinate form. Okay, we're done with that, and then we are at the last question for question 5. So it says, write down the values for which f of x times g of x is smaller and equal to 0. So what are they saying? They're saying the y values for f multiplied by the y values of g are smaller and equal to 0. If they are smaller and equal to 0, they are negative, right? So either f has to be negative and g has to be positive to get a negative, or f has to be positive and g has to be negative in order to get a negative. And let's look at our graph. Ooh, and it's not drawn to scale. But it's fine. We'll figure it out. We'll see. So, do you see here g is negative? G is positive here, right? So g is positive while f is negative. Okay, until they get to 2. So this is where 2 is. Okay, until f gets to 2, because after that, f is positive and g is also positive. So I'm going to get a positive answer. But before 2, do you see that if I multiply the y values of g and the y values of f, I'm going to get a negative. Okay, so I know that it's actually from negative infinity to 2. And I am including the 2 this time, okay? Because it said it could be smaller or equal to 0. So I'm including the 2 because value at 2, that's where f is 0, okay? Now going forward, f is still positive. G is still positive. F is also positive, so that doesn't work. But until we get to, let's say at negative 1. Okay, so at negative 1, g is 0, okay? And f is positive. Okay, so there we have a 0. And then going forward, g is negative and f is positive. Do you see? And it goes all the way where g is negative and f is positive until it reaches 6, where it is 0 again. Okay, so in this case, we know that x is in between -1 and 6. Okay, so when you write down our answer, remember they say they want the x values. So when you write down our answers, finally, we're going to say x is an element of, remember with infinity, it's always round brackets. So negative infinity up until -2, right? Was it -2? Yes, I didn't put the negative there. Should be -2. Okay, and then we're going to go from -1 to 6. So -2 is included. And then we're also going to have -1 all the way to 6. Is that correct? Yes, all the way to 6. And that is our answer. I hope you learned something. I hope you saw your errors if you made mistakes in the paper. And I hope you're going to learn and grow from those errors. Okay, please don't forget to like our video and our videos and subscribe to our channel. Thank you guys. Bye. Hello everyone and welcome to MV Tutors. I'm Tsulu and I'll be looking at question 6 with you guys. We're doing the prelim that was just previous, what is it? It was written recently. Ooh, English can escape. So so we're just doing the memo with you guys. So let's see what question 6 has in store for us. Okay, so this is financial maths. I think you should enjoy this topic. I mean, it's normally you ask, why do we need maths and all of that? You can see that, no, notifications. Please do watch that video. I forgot to switch off the Wi-Fi. Okay, it's all good. So anyway, we are doing financial maths. It's applicable in real life. That's why I love it. Because really, if you want to learn more about money and have a good relationship with money, you should invest in this topic. Okay, yeah. Okay, so let us see question 6. So it says Janet invests a lump sum of 5,000 into a savings account for exactly 2 years. Okay, I'm just gonna write down the info as we go. So she invests a lump sum. Okay, so her investment amount is 5,000 Rand for exactly 2 years. Okay, the investment earns interest at 10% per annum, compounded quarterly. Okay, so what if it's compounded quarterly? You're just gonna take that 10% and divide it by 4, and then we're gonna go back to n. Okay, so it's not in years. We must turn it into quarters. So for it to be quarters, there are 4 quarters in a year. So 2 times 4. So you're going to have 8 quarters. Okay, now let's see what are the questions saying. What is the quarterly interest rate for Janet's investment? So the quarterly interest rate, we have already written it down. Okay, 10 divided by 4 is actually 2.5%. Okay, and then 6.1.2, calculate the amount in Janet's savings account at the end of 2 years. Okay, guys, so which equation do you use? Okay, let's go to the formula sheet when it comes to finances. Okay, so the finance equations. Oh no, what did I do now? Okay, so yeah, let's use a different color. So I see 1 over here. This is when you have the present value. Present value meaning you were given money today. Okay, either maybe in a form of a loan or inheritance. Okay, then we have future value meaning you're gonna get money in the future, via investments. Okay, and then we have all these other formulas. So when do we use what? If you have a lump sum and you are investing it for a certain amount of time at a certain interest rate, you will be using these equations. Okay, so in terms of an investment, this is a lump sum. And if it was compounded, annually or monthly or whatever, okay, so the interest is compounded, it's not simple, we're going to use this equation for compound interest. But if it was simple interest, then you're going to use that. Okay, so this is for lump sums. Lump sum. Okay, but if you are going for monthly payments, okay, like maybe if you're paying off a loan and they tell you at the bank you're going to have to pay X amount every month, okay, you're going to go with this equation. And if you're investing and you keep putting in, periodic payments, okay, regular payments, equal amount of payments regularly over time, then you would use that one. It's not a lump sum. And actually, if you do the calculations, you'll find that if you want to get better interest, go for your annuities. Annuities are the regular payments that you make monthly, quarterly, yearly, or whatever. Okay, those are the best instead of just putting a lump sum. Okay, so yes, this person has a lump sum, so we're definitely going to use this equation. Okay, so let us just go back. Question 6.1.2, calculate the amount. So she put in a lump sum. We're going to use this formula. So P, as we had it, is 5,000. And then the interest is 2.5%. And the N, we have 8 quarters. So you're just going to put that in the calculator. So 1 plus 2.5. Where's percent? Okay, percent. And to the power 8. So we have 6,092 Rand and 01 cents. We always round off to 2 decimal places. Okay, now Sihle inherits 800,000. Okay, so basically he got 800,000 today. So the present value amount is 800,000. He invests his entire inheritance in a fund. Okay, so he's taking a complete lump sum of it and he invests it. Okay, in a fund which earns at a rate of 14% per annum, compounded monthly. Okay, at the end of each month, Sihle withdraws 10,000 Rand. So he's taking out 10,000 Rand from his fund. His first withdrawal is exactly 1 month after his initial investment. Okay, so if they say 1 month after his initial investment, we're going to use the present value formula as it is. You're not adding anything to the months or subtracting anything. You're using the equation as it is. Okay, so we haven't even read the question. That's me. I just like going ahead. So 6.2.1, it says, how many withdrawals of 10,000 will Sihle be able to make from his fund? Okay, remember, this fund, he's invested it, so it's gaining interest, but at the same time, he's taking out. So we need to determine how many withdrawals he can make overall, okay? And we're going to use the present value formula. All right, so where we have P is equal to X, 1 minus 1 plus I to the power negative N all over I. Okay, so what values do we have? So we know that P value is 800,000, and then we know X is 10,000. Okay, and in the bracket we have 1 minus 1 plus, the interest is 14% over 12, and we're trying to get N. That is the whole objective of this question, to calculate what N is. Okay, so now I'm just going to make N the subject of the formula. Ooh. Let us see. So I have 800,000 divided by the 10,000 multiplied by the 14% over 12. Okay, which is then equal to 1 minus 1 plus 14% over 12 to the power negative N. Okay, so now I want to know, I'm going to do everything at one go. And hopefully that turns out fine. Okay, so I have 800,000 multiplied by 14% over 12. Okay, all over 10,000 minus 1. So I've took 1 to the other side. Now I have a negative 1 plus 14% over 12 to the power negative N. Okay, now I'm going to simplify it a bit. I don't want to load myself. Okay, so we have 800,000 multiplied by 14% over 12, and that is all over 10,000. 1, 2, 3 minus 1. So the answer is negative 0,0666667. I'm just going to do it like that. And then on this side, I have negative. So in the bracket, I am going to, so I'm just going to store this one. So shift store A. Okay, yeah. So if I say, let me see if it's stored it, alpha A. Yes, it's stored it. Great. Okay, so I have 1 plus 14% all over 12. I shouldn't have used brackets, but I have 1, 0, 11667. Okay, and it's negative N. So the negatives are going to cancel out, and then I'm going to have to use logs. So the negatives cancel. So now I have negative N is equal to log 1, 0, 1167 times 0, 666. Yeah. So let's get what the answer is. So what I'm going to do, I'm going to say log of the answer that I had times alpha A. Remember, I saved that answer. I don't like rounding off early. I want to round off everything at the end. That's why I save the answers. So let's see. Oh my gosh. Oh no. Okay, so I have negative 233. So negative N is equal to negative 233,47. Okay, thank you, calculator. You have done your job. Now, how many withdrawals of 10,000 can Sihle make? Well, When we're calculating for n, we do not use fractions or decimals. We must use whole numbers. So the negatives cancel, and then I'm left with 233 withdrawals. This other decimal just means that after he makes 233 withdrawals, there'll still be some money left. Okay. Cool. Ooh, how many marks was this? 5 marks. Okay. See why. And then 6.2.2, it says exactly 4 years after his initial deposit. Okay, so I'm thinking 4 years. How many months? Because this thing is compounded monthly. 4 times 12, which is 48 months. Okay, exactly 4 years after his initial deposit, Sihle decides to withdraw all the remaining money from his account to use as a deposit towards a house. That's actually a good idea. Invest in property, please. Okay, so A, what is the value of Sihle's deposit to the closest rand? Very important key there, closest rand. So after we calculate, we shouldn't say round off to 2 decimal places. It must be a whole number. Okay, so if they want the value, do you see that we're actually getting the outstanding balance after 48 months? Okay, and I do not think they have an outstanding balance formula. But basically what you do, remember Sihle put in a lump sum of that 800 in an investment. Okay, don't forget about that. It's a very important fact. So if you want to know the outstanding balance, what you would do is you first have to calculate that lump sum. Okay, my son just woke up. Let me pause. I'll be back. Okay, sorry about that. I even wrote the wrong thing because I was distracted. My son wants cereal, jungle oats to be specific. So 1 plus I. So you're going to take that lump sum that you put, right? It's gaining interest, okay? Over those 48 months when he was busy withdrawing the 10,000, the 800K was actually accumulating interest, okay? So for the outstanding balance, you're going to take that and then you're going to subtract your future value amount, because we want to know in the future what would the amount have been at 48 months. Okay, so it's gaining interest at 48 months, okay, as well as there's a future value that you have or expecting over or at 48 months, okay. And the future value formula, if we just have a look there, so I'm just going to say outstanding balance, okay. I'm just going to write the equation again, 1 plus interest, and then minus the future value, x, and then we have 1 plus I to the power n, let's just make it bigger, to the power n minus 1, close brackets, and it's all over I. Okay, and we know that our values, okay, so the value for P, just take it up, 800,000, and 1 plus the interest rate that we had, it is 14%, okay, compounded monthly. All right, and then, sorry for the background noise. And N, we calculated it, guys, it was over 48 months, okay, and then we're going to subtract the monthly payments there, 10,000, okay, so 1 plus the interest rate is 14% over 12 to the power 48 minus 1, okay, close the big bracket, all over 14% over 12. That is the outstanding balance formula. Okay, let's just go over it again. You have this 800K, Remember, he invested it. He inherited 800,000 and then he invested the entire inheritance. So you want to know the value of that inheritance after 48 months. At the same time, he was busy withdrawing 10,000 Rand. Okay? And we need to then get that value that he was busy withdrawing at 48 months. So we're going to plug this into the calculator. Let's plug all of it in the calculator. Let's risk it. 800,000 times 1 plus 14% all over 12, okay, to the power 48. Okay, you could actually just get the value here, but because I don't want to wash down my values, I want to take it everything as is. Okay, so another bracket, and then we have 10,000. But the danger here is if you make an error, ooh, you are screwed. Okay, so 14% all over 12. I was actually thinking, is screw a swear word? I'm sorry, guys. I didn't mean to swear. Okay, we have minus 1, and then we're closing that bracket. Okay, all over 14% over 12. Okay, we survived. So now the outstanding balance that he has at 48 months is 757,428 Rand, 18 cents. Now remember, they said to the closest Rand. So we're not putting in those cents. Okay, so this is the amount. Okay, not so bad, ne? So whenever you are getting the outstanding balance, guys, get your lump sum formula, compound formula, not simple interest, and then subtract it by the future value formula. That is the outstanding balance formula. Okay, they won't give it to you on the question paper, but put it down for yourself. As soon as you get to the exam room and they give you and you start, and financial maths, most likely they will put in outstanding balance. So just write it down for yourself. Okay, so we have it. Now B, we are almost there, guys. We're almost done with question 6. Now Sihle's deposit is exactly 30% of the purchase price of the house. Must be some expensive house. But anyway, times these days, things are so expensive. You can't get a proper property for less than 1 million. So Sihle's deposit is exactly 30% of the purchase price of the house. What is the purchase price of the house to the nearest Rand? Okay, so they are saying 30% of that property, I'm going to say purchase price, okay, is the deposit, 757,428. So now they're asking, what is the purchase price? Okay, so the purchase price will be 757,428 divided by 30%. Okay, so in my calculator, I kept that value. Okay, like I said, I like using the value as it is. So I'm going to take the answer and divide it by 30%. Okay, so to the nearest Rand, we have 2,524 Rand and 761 or 760. 761 is not a nice answer. Should have put it at 760, but I'll put 761. Okay, but that is to the nearest Rand. So that is the purchase price of the property that Sihle wants. I'm just glad he's investing in property. As for how much, yeah, that's another story. So yeah, we are done with question 6, people. I hope again you've learned something, and if you remember your answer from the paper that you wrote, please don't feel bad that you're not getting the exact answer. Just take it as a lesson. Where did you go wrong? And make sure that for the November exams, you don't do the same mistakes. Okay? You don't make the same mistakes. Alrighty, thank you so much for tuning in. Please don't forget to like our videos and subscribe to our channel. Other than that, have a beautiful day or night, depending on when you're watching this video. Okay, bye.
Welcome to MV Tutors. My name is Figa. We are doing the prelims right now. You literally wrote this exam yesterday, matrix. Yesterday, literally. So this is our secret. Don't tell the government that we are taking this out so early, the memo so early, but oh, here we are. Anyway, let's do question 7 now. So question 7 says, given that g of x is that, determine f1 of x from first principles. Okay, so first of all, we need to know what first principles is. Okay, and it's this idea. First principles is this idea that f1 of x would be given by, really will be given by the limit as h tends to 0 of f of x plus h minus, let me give myself some space here, minus f of x, and all this divided by h. All right, so first of all, let's get what f of x is. Well, in this case, it's g of s, but it's fine. Let's just call it for f of x for simplicity's sake. So f of x is equals to 1 minus 4x squared, right? So let's just work with this, being given much more space. So what this means is that f x plus h now is gonna be equals to 1 minus 4, and when we have an x, we'll put x plus h. We'll square that, and then we'll work it out. Now, normally what I do in such situations where I have a square and I need to multiply it out, for simplicity's sake, I just open two brackets like this, and then I always draw these lines, because under exam pressure it's very easy to make a mistake and forget. So I just follow these. So x times x is x squared, x times h is plus xh, h times x is plus xh, and then finally h times h, which gives me h squared. Okay, so what I'm going to do now is just clean it up a little bit. So I'll have x squared plus 2xh plus h squared. Right, now let's get rid of the brackets. Now all I'm gonna do is multiply that minus 4 there, multiply it in there and there. So first one is minus 4 times that x squared is minus 4x squared, minus 4 times 2xh is minus 8xh, and then minus 4 times h squared is minus 4h squared. So what I'm gonna do now, I've solved my f of x plus h, and I have my f of x. I'm just gonna substitute it back into that formula over there and then continue working it out. So then I'm gonna say f1 of x is therefore equals to the limit as h tends to 0 of f x plus h. I'm just going to substitute this whole thing, which is going to be 1 minus 4x squared minus 8xh minus 4h squared, and then minus f of x. F of x is that, I'll put it in brackets, it's 1 minus 4 x squared. Now, ladies and gentlemen, this has to be divided by h. Like that. Cool. Let's continue with that. Unfortunately, you just have to write this h, this limit thing again. What I want to do is just get rid of this bracket. Everything else just remains the same. No issues there, which is rewrite it exactly as it is. So minus 1 times 1 is minus 1. Minus 1 times minus 4 is plus 4xh. Okay, so you need to be careful of these brackets. Okay, so now we can combine like terms and subtract what subtracts. So this minus 4 plus 4, they cancel each other. This 1 minus 1, they cancel each other. And then I'm left with, I have to rewrite this thing over and over again. I'm left with minus 8xh minus 4h squared divided by h. That's what I'm left with, right? So let's write it probably for the last time now as h tends to 0. What I'm gonna do is factorize, so take out h because it's common between both terms, and then here I'll be left with minus 8x minus 4h. Okay, divide that with h. These h's cancel each other. And then what I'm going to do now is actually do the substitution. So when I do the substitution, I no longer need to put the limit. So I'm going to have minus 8x minus 4 times h. That's where I substitute the 0. Then my final answer is minus 8x. That then is equals to my g1 of x, because they wanted g1 of x, right? So there we go. That's it. We're done with that question. All right. Okay, so here we go. 7.1.2, hence calculate the gradient of the tangent of f at x is equals to 2. So you need to know a bit of theory about this one. What you need to know is that the gradient is actually equals to f1 of x. Okay, so that's the formula for the gradient. And f1 of x, we've calculated it to be minus 8x. So what that means is that at 2, that means we have to substitute 2 there. So that we'll have minus 8x times 2. Okay, where x is. So that it's minus 16. So that's the gradient. That's the gradient at that position of x is equals to 2. Okay, that's it. And then the next question is, if we read it here, 7.2, I just want to bring it this side this time so that I use the space this side. Let's use a different pen. It says 7.2, it says determine f1 of x if f of x, so f of x is equals to 3 square root x squared, okay, plus 1 divided by 4x to the power 4. So now we have to rearrange this first in so that we can differentiate correctly. It needs to be in one line. Okay, so here we have x squared, but because it's a cube root, so it's times a third. Okay, and then here we'll have plus. Let's bring this 1 over 4. That's the number, but let's bring the x to the power 4 to the top, so it becomes minus 4. Okay, so I just want to rewrite this nicely. So it's x 2 over 3 plus a quarter x minus 4. Now we can do F1, we can differentiate. Okay, and we're gonna bring this down. It's 2 over 3x, and then it's 2 over 3. We need to subtract 1, so I'll subtract 1 as 3 over 3 because it's fractions. That's how you deal with fractions. Plus 1 over 4, that's that number, and then that will be multiplied with a negative 4. Okay, and then x minus 4 minus 1. Okay, let's clean this up. Finally, it will be 2 over 3 x minus 1, because 2 minus 3 is minus 1 over 3, minus, because these 4's cancel each other, and then you're left with the minus 1, and then x minus 5, because it's minus 4 minus 1, which gives you minus 5. That's our final answer. Cool. We're done with 7.2 now. Let's go to 7.3. Okay, so 7.3 says, given that, determine the value of a if it is given that h. All right, okay, this one is a bit tricky, but we're gonna do it. We don't mind tricks, because you must assume that each and every question is a trick question. Okay, so we're doing 7.3. Now they're saying h of x is equals to ax squared, right? Okay, now and then they further tell us that over here, the first one that we have to deal with is the inverse. So if you have an inverse, it's y is equals to a x squared, and then the inverse of this. Okay, so this is h of x. This is h of x. H of x is given by this. But now h minus is given by x is equals to a that is squared. So that's what we have to solve now. We have to solve this in terms of y. Make y the subject of a formula. In doing that, we're gonna divide both sides by a. Okay, and then I will have y squared is equals to x over a, right? But to have y, that's going to be equal to the square root of x divided by a, because to get rid of a square, I square root both sides, like that. Okay? So now I have that. And they are telling us in this question that if you substitute 8, that will be equals to when you derive this once and substitute 4. So let's just derive it once. Okay, so now we have h of x. Again, I'm gonna just write it like that. It's a x squared, so h1 of x is 2ax. Now they are saying to me, if you read the question, it's just, you see. So what we have to do then is that we have to take h1, h minus 1, and substitute 8 and make it equals to substitute 4 there. Okay, that's basically what we have to do. Fortunately, we do have the numbers that we need, the equations that we need. The inverse is given by that, so I'm going to say square root of x, and x is 8 divided by a. That is now equals to the derivative, and then I have to substitute 4 in there, so I'll put 4 there. Then I have square root of 8 over a is equals to 2 times 4 is 8a, and then I need to get rid of this square root. Do that by squaring both sides. Okay, so that I have 8 divided by a is equals to 8 squared is 64, and a squared. Now I have to solve for a, so I just multiply both sides by a times a, and then these a's will cancel each other, and I'm left with 8 this side is equals to 64 a cubed, right? So finally then I'm gonna have 8 divided by 64. What's going on here? Misbehaving. 8 divided by 64 is equals to a cubed. Now I have to get rid of the a cubed. So what am I gonna do? Yes, you guessed it. I'm gonna cube root everything on both sides. Cube root this side, cube root that side. Fortunately, I know the cube root of 8 is cube root of 8 is 2 over, and then the cube root of 64 is 4. The cube root of a cubed is just a. Therefore, a is equals to a half. That's it. That's how you answer that question. Thank you very much for listening. But in the event that you didn't understand some of the things that I was doing, please do contact me on my website www.mvtutors.co.za, or you can WhatsApp me on 076 312 1107. And please don't forget to like and subscribe this video so that we can have it reach a bigger audience and help more people with these questions. Okay, thank you so much, and that was it. Well, welcome to MV Tutors once again. It's me, Figa. I'm your tutor today. You wrote this yesterday. Literally, this exam was written yesterday. I just want to remind you of that. So yeah, okay. So let's look at this question 8. We're doing the prelim Gauteng question 8. There we go. Mathematics paper 1, written yesterday. Consider the graph of. I'm very proud that it was released yesterday. You were writing it yesterday. I'm very proud of that. And I'm very proud that we'll be the first ones to take it out this time. Right. So it says determine whether the graph of H intersects the graph of G at its point of inflection. Show all necessary calculations. So we need to understand this question practically. So first of all, they are talking about this idea of a this idea of a point of inflection right over there. As you can see, they're talking about the point of inflection here of G. So let's do it step by step. Now let's solve the point of inflection first, and then what we're going to do is that once we solve it, we're going to use that x value to substitute into h of x. Now if it gives us the same answer as the same y value, then it means they intersect. Okay, but let's just one step at a time. Point of inflection. So if you have g of x and it's equals to x cubed minus 3x squared. Now the point of inflection, remember we have to do derive g of x to the second degree. So we'll do the first degree, okay, which will be 3x squared minus, what's 2 times 3? It's 6x. And then we'll do it to the second degree. It's just how you solve a point of inflection. Okay, so what you do, okay, 3 times 2 is 6x. And this side it's minus 6. So what you do to solve a point of inflection, what you do is that you take the second degree derivative, you equate it to 0, and then you solve x. Okay, that's what you do. Let's come this side, let's give ourselves more space. So now we do have g to the second degree, it's 6x minus 6. We equate it to 0. Let's just do some mathematical gymnastics now. Take the 6 to the other side, divide both sides by 6, so my x is 1. Okay, so this just gives me the x value where the point of inflection is. I still need to substitute it back into the original equation, okay, so that I can solve my y. So it's g of 1, so it's going to be 1 cubed minus 3 times 1 squared. So that just becomes 1 minus 3. 1 minus 3 is minus 2. So my coordinate, my point of inflection coordinate is therefore 1 and minus 2, right? So think of that. That's my coordinates for point of inflection. So what we have to do now is just grab this equation right here of h of x. Just put it there. So now my h of x, therefore, is equals to minus 2 over 3x minus 4 over 3. So what I have to do then is substitute that x value, which was 1. If this gives me minus 2, put a 1 there, then they do intersect indeed. Okay, so now I have, let's just clean it up a little bit. It's minus 2 minus 4 over 3. So what's minus 2? Minus 2 minus 4 gives me minus 6, right? So it's minus 6 over 3, and minus 6 over 3 is minus 2. So there, again, we have 1 and minus 2. So I can therefore conclude and say that Okay, let's go back to the question just to make sure. Determine whether the graph of H intersects with the graph of G at its point of inflection. So I can conclude then and say, yes, the graph of H intersects with the point of inflection of graph. What is this graph? Is it G of graph G? That's it. So that's how you answer that question. We are done. All right, let's see the next one. The next one says determine stationary points of y is equals to G. Okay, so now we have a situation where just put this here. We have a situation where our y is now equals to g1 of x. Okay, and then what is g1 of x? G1 of x is 3, this one, 3, 3x squared minus 6x. Okay, it's 3x squared minus 6x. Cool. So that's our y, right? So now they're saying determine stationary points of this. So that's a turning point. Now there are many ways to solve a turning point, but the easiest way I find is using the equation, this equation. This gives you the x value, only the x value. Okay, so maybe let me do this. Let me rather put it this way. Let me say the turning point x value is equals to that. Okay, so then what's my, okay, this is my value of a, that's my value of b, so it's minus, b is minus 6, right, over 2 times a is positive 3. So then this gives me, a minus to the minus is positive, so it's 6, divide 2 times 3 is 6. My turning point is at 1. Okay. Now, determine the stationary point. Let me just, this gives me the x value. Now, to get the y value, okay, to get the y value, I have to substitute it back into the equation so that I will have, I'll put 1 in there, and then I'll have 3 times 1 squared minus 6 times 1. Okay, so what's 3 times 1? 3 times 1 is just 3 minus 6, so it's equals to minus 3. So then, therefore, my turning point coordinate is at 1 and minus 3. Okay, cool. So what did they ask here? And then classify whether it's a maximum or a minimum. All right, if you know what's the gradient, all you have to do is look at the gradient. If the gradient is positive, then it's a smiley face. Remember this, a positive gradient gives you a smiley face. Negative gradient gives you a sad face, a sad face thing. So a positive one gradient has a local a minimum, but negative has maximum. In this case, we have a smiley face because it's a positive gradient of 3, positive 3. So then we are going, where is it? It's a minimum. Therefore, minimum. That's it. Okay, let's do question 8.3 now. It says, hence or otherwise determine the values of x for which G is concave down. So now it's talking about the actual graph of G. What's the graph of G? Oh, it's the cubic graph. Okay, so there are a few things that we need to know about cubic graphs. Number one, we must know 3.1. We must know that a positive graph ends with a smile. Okay, but it starts being sad, so it's like this really. Okay, and then a negative graph, it's not about how you start, it's about how you end. That's how I remember it. It ends with a sad face, but it started with a smile. Okay, so when they are talking about concave down, they are talking about it being sad, the part of the graph. So they are looking for this part, and it's only said from here to the point of inflection. Now we have solved that the point of inflection is at 1. All right, the point of inflection, the x is at 1 and -3. Doesn't really matter. What we are concerned with is the value of x. Okay, and then this graph continues all the way to infinity. So really, if you think of it, okay, it's from -infinity to a +1. Okay, but you can just rewrite this by saying where x is less than 1. That's it. That's it. That's it. That's all you have to do for 8.3.1. Sorry about that. Okay, let's go to 8.3.2 now. Let's use blue. There. Hey, I haven't used yellow. 8.3.2. So it says the gradient of the tangent to G at its point of inflection. So we know we know that the gradient is given by this first derivative of x, right? And what was the first derivative of x? Okay, it's that one, yeah, 3, there, 3x squared, yeah. It's that one for, it's given by 3x squared minus 6x, yeah, I think so, minus 6x, that's it. So when they say the gradient of the tangent at the point of inflection, the point of inflection is at 1, x is 1, as you can see over there, x is 1. So all we have to do then is just substitute 1. So we have to substitute 1 into the gradient equation so that it gives us that value over there. So it's going to be 3 minus 6, which is minus 3 as a final answer. Okay, so that is the gradient of the tangent to G at the point of inflection. Now 8.3.3 says a student claims that the gradient of G at any point will never be less than -3. Is the student correct? So what we want to potentially do here is just solve the minimum value. Okay, and to get the minimum value, let's use green, it's 8.3.2. to get the minimum, we have to go to the second degree of deriving and equate it to 0 and then solve x. That's what we have to do. Okay, so let's get the second degree thing. So it's gonna be g x, we'll just derive from here. It's gonna be 6x minus 6, and then we equate this to 0 and solve for x. So I'm gonna have 6x is equals to 6. If I take the 6 to the other side and then divide 6 on both sides, I'll get that my x is 1. So this is the absolute minimum. Okay, and then what we have to do then is take this minimum value and put it into the original equation. Okay, g of x. What was g of x? Okay, and then solve. It's x cubed minus 3x squared. Okay, so it's x cubed minus 3x squared. So if we substitute 1 there, it should give us the minimum value, absolute minimum. So 1 cubed minus 3x squared. What? Hold up, nigga. Just hold up a little bit. What are they talking about? The gradient of g at any point will never be less than, okay. Okay, I'm cool with that. Let me just check. Okay. So, sorry. So, actually, this is why I don't mind making mistakes, because I need to teach you what you should do when you make a mistake. When you make a mistake, you correct, you re-evaluate, and you try again. This x1, we need, this is the minimum value, okay? So we need to actually substitute it back into the gradient equation, okay? And when we do that, it gives us minus 3. Therefore, we can conclude that the student is right. The student is right. Okay, it's just a theory that if you go to the second degree derivation, it will give you the minimum x value. Okay, and then if you put it, because we're talking about gradients here, so you have to substitute it into the gradient formula. Okay, and we know that if you substituted 1, it will give us minus 3. So the student is right. You can't go any lower than 3, minus 3. Okay, let's go to the last question now. It says determine the value of Ka if the graph of G is shifted so that the values of X for which the new graph P, okay, decreases is between minus 3 and minus 1. All right, so the first defense of every question is understanding what the question wants. Because if you don't understand what the question wants, you are going to answer the wrong thing. So first of all, they are telling us that the graph is shifted such that it decreases from these values. By decreasing, okay, let me put it into perspective like this. Let me actually, all right, so let me put it into perspective like this. This is the graph, right? It's like this. The graph decreases from the turning point to this turning point, because you know when you're driving from this side, you are increasing. As you hit the graph, you increase, you go up, you hit the turning point, and then you start coming down, and hit that turning point, it start going up. So it's decreasing from that point and that point. Currently, we know That's the point of inflection is at 1. That's the x value. So I'm just going to write the x values because that's what we're concerned about, is at 1. Okay. And then, do we know anything about these turning points? Let's see. Did we solve for turning points actually? No, we didn't. So we need to solve the turning points for this graph. All right. Let's go use blue. The turning points for, so to get turning points, for a cubic graph, you go to the first derivative, equate it to 0, solve x. It will give you the turning point. So do we have, and it's g actually, so it's g of x. G of x, I'm sure we solved the first. Let me just write the first derivative because we've been working with it. Okay, and it's equals to 3x squared minus 6x. So remember I said equate it to 0 and then solve for x. That will give you the x values. So in solving for x here, I'm going to factorize, take 3 out, take x out. Okay, and then I'll be left with x. To get minus 6, I must multiply 3 with minus 2 equals to 0. So then I can therefore conclude and say x is equals to 0 and x is equals to positive 2. So what does that mean for my graph then? It means, let me just put a grid so that it's more into perspective. I don't know if you can see this grid. Should I go this one? Yeah, let's use this black one for consistency's sake. So what we have here is that we actually have a graph, right? Let's just make it, that's our a Cartesian plane. Now I haven't substituted anything, right? But I do know that it's, first of all, it is a positive gradient graph. So it's exactly like that, this green one I have here. So but I know that I have a, so the graph is supposed to look like this, but I know that I have a turning point at 0. Okay, let me start with the point of inflection. It's at 1. That's 1, that's 2, that's 3, that's 4. It's at 1 and minus 3. That's minus 1, minus 2, minus 3. It's at 1 and minus 3. Okay, that's my point of inflection, and it's like that. So I'm not concerned with the y values, but I know that my other turning point is here at the value of 2. I don't know if I substitute 2. Let me just draw it accurately. If I substitute 2 into the original equation of g, I put 2, that's gonna be, remember my original equation, I need it. I need the original equation. Is x cubed minus 3x squared. So it's x cubed minus 3x squared. So if I substitute 2 there, it's going to be 2 cubed minus 3 times 2 squared, which will give me 8 minus 3 times 4, which will give me 8 minus, what's 3 times minus 12? That's minus 8 minus 12 is minus 4. Okay, so I wasn't so far off. at minus 4. It's there. Okay, because I have a minus 4 there. And then if I substitute 0, if I say g is 0 now, I'm gonna get 0 cubed minus 3 times 0, which gives me 0. So the other one, turning point, I must have made a mistake here. 8 minus 3 times 4 is 12. 8. Anyway, really, it's just the, because now what I'm getting is that at 0, it's at 0. It's right there. Minus 4. It should be like 1, 2, 3. 1, 2, 3. It should be like minus 6. My answer should be minus 6 here. So 8 cubed, 2 cubed is 8. Wait, did I write this correctly? Equation 3, x cubed plus 2. It's 2, man, not 3. Is it 3? 3. Anyway, that's fine. I'm gonna put it there then, 0, 0. And my point of inflection was 1, unless if my point of inflection is not minus 3. It's minus 2. Now it makes sense. Okay. Now I'm taking you through the process of my mistakes so that you know what to do. And then, now it's making sense, because now I know that my graph is gonna go like that and then turn over there, whatever, continue to positive infinity. It's turning here, continues to negative infinity. So this is my original graph. Now, as you can see, it is decreasing from 0 to 2. All right. But now with the new graph, they are telling me here on the equation that it decreases from minus 3 to minus 1. So let me show you what that means. So they are saying at minus 3, let me just put minus 1, minus 2, and minus 3 over there. So now it's decreasing from minus 3. Let's use the red one. From minus 3 to minus 1. It's decreasing like that. And then it will start turning. So now this is my new graph. Okay, this red one. So if you look to get your value of k, then all you have to do is look how many times did it shift to the left. That's all you gotta look at. Okay, and then we can then conclude that it shifted. Let's count. 1, 2, 3. So therefore k is equals to 3, because it shifted 3 times. All right, and remember, a shift to the left is a positive number, so that's why k is a positive number. There's a positive number there, and then a shift to the right is always the opposite, which is a negative number. This was a shift to the left, so k has to be positive. That's why k is equals to 3. Well, that was a mouthful. That was, we struggled over there. But just in case there's something you're still missing, you don't understand, do contact me on my website, www.mvtutors.co.za, and book a session, a free consultation. I give you a free consultation. And then you can also WhatsApp me on 076 3121107, and you will get me over there. All right, so thank you very much. I hope you enjoy the rest of your day further. Well, welcome once again. My name is Figa, and we're still doing the exam paper you wrote literally yesterday. Yesterday was Friday. Today, the day of recording is a Saturday morning. So we're taking out this memo first. Definitely. So this is your prelims, your Gauteng prelims. We're on question number 9 now. It says the bracelet below is beaded by using 10 plastic spheres and 10 plastic cylinders. Okay. When completed, the bracelet will be painted. Ignore the holes in the spheres and cylinders. The following formulas are given. So let's just get this down right. This is the volume of the cylinder, this one. Not cylinder, cylinder. This is for the cylinder. And then this is the volume for the other one, the sphere. And then likewise, this is over here is this is for the cylinder, and then this one here is for, wait a minute, this one is missing an R. There should be an R here. The surface area for a sphere, it's missing an R. I mean, not a sphere, man. Why am I getting this confused? This is for the cylinder, surface area for the cylinder. It's missing an R there. Because, yeah, that's how cylinders are. They just, they got a top and a side. So that's it. That's the formula right there. Anyway, so let's read the question. It says the following essential properties of different beads are: the radii r of the sphere and the cylinders are exactly the same. Thank you very much. That's important information. The height of each cylinder is h. Now they say if the volume of a cylinder is 6. Okay, cool. So that requires you to know which one is the volume of a cylinder. So the volume of a cylinder is pi r squared h, and they want us to solve h in terms of r, where the volume is 6, so we'll put 6 at the volume, and then all that's left now is just to do mathematical gymnastics. We can just divide everything. So h is there. We divided both sides by pi r squared, and then that gives you, well, ladies and gentlemen, it's as simple as that. That's 9.1. We are done with it. 9.2, show that the total surface area of all the painted surfaces of the bracelet is equals to that. Now, I wouldn't worry about what, I always never worry about what they actually say. I'm just gonna solve it as normal, and if it happens to be equal, then I'll know that I'm on the right track. So 9.2, the total surface area. So to get the total surface area, I must add the surface area for the sphere, which is 4 pi r squared, and then I must add the surface area for the cylinder, which is 2 pi r squared plus 2 pi r h. Okay, so everything is in terms of pi and r except the h. So what I'm gonna do now is just substitute h, because I've already solved what h is, right? I solved it on the first question. So it's 2 pi r, and then h is 6 divided by pi r squared. Okay, then that allows me then to okay, so that pi will cancel that pi, and that r will cancel one of the two, so I'll be left with 1. So finally, what's 2 pi r plus 2 pi r? That is 6 pi r plus what's 2 times 6? 2 times 6 is 12, okay, over r. Okay, so that's pretty much it. But now they said 120. Okay, so where is that 120 coming from? Okay, let's look at this again. Let's look at our values. We got pi r squared and we got h. H is that. Okay, I think we're fine. We can leave it like this, really. I mean, this if I want it to be exactly 60 and 120, that's also fine, because what I can do then is just multiply everything by 10 like that. And what that's gonna do is that it's gonna give me 60 pi r squared plus 120 over r. That's it. Can do it like that. No problem, no issues over there. I got no issues. Okay, now you might be asking yourself, where is the 10 actually coming from? Well, if you read over here, it says 10 plastic spheres and 10 plastic cylinders. So there's 10 of them. So I have to multiply by 10, because this formula is for one of them. But since there's 10 of them, I'll just multiply by 10 so that I get the formula for all of them. Cool, let's move over then to the last question. Determine the value of R so that the least amount of paint will be used. Okay, so you use paint on the surface area, right? So that means that let me do it like this. This is 9.3. It's a different color. This is 9.3. So we know that if we take the first derivative, equate it to 0, and then solve x, it'll give us the minimum amount of paint. But here, what we are dealing with then is this formula. Okay, so let me I want to rewrite it, but it feels a bit far. So I'm gonna do it here. So the surface area in terms of R is actually equals to 60 pi r squared plus 120. Now I want to bring that r on top, so it becomes -1. That helps me to solve it, to solve the derivation. So s prime will then be equals to 60 times 2 is 120 pi r, and then this is gonna be equals to minus 1 times 120 is -120 r, minus 1 is -2. Okay, determine the least amounts. Okay, so now what we're gonna do is solve for r. We're gonna equate this to 0, so it's gonna be 120 pi r minus 120, I'll put it underneath. R squared equals to 0, and then I need to solve for r. So I multiply everything by r. If I'm just to get rid of this fraction, r squared, I'll multiply everything by r squared. So if I multiply by r, it's just mathematical gymnastics at this point. Okay, 0 times r squared is 0. So if I take 120 to the other side, okay, then what I'm gonna be actually left with is if I want r, divide both sides by 120 pi, okay, then I'm gonna have r is equals to 120. Let me just put it, divide both sides by this thing to get rid of that. So then I'm gonna have it, r then is equals to 1 over pi. Okay, so now what does that mean? This is the value of r, meaning I have to, oh my goodness, why do I keep making mistakes? I forgot it's cubed like that. That's all. So to get rid of the cubed, then I have to cube root both sides, right? So I have r cubed is equals to 1 over pi. So to get rid of the cube, like that, cube root both sides. Then I'm gonna have r is equals to cube root of 1 is 1, and then I'll just leave this cube root of pi. Okay, like that. We can actually put this in a calculator if we want. Okay, let's just go ahead and do it right now. Let's get our calculator. Come here, calculator. Okay, so fraction, we put 1 on top there. Come downstairs, cube root. Where's cube root? It's there, it's orange. So I need to go shift and then press it. There we have a cube root. Where's my pi? It's also orange. So I go shift, put a pi in there. Good. What does that? Gives us 0.68. So we have 0.68, and that is our final answer for R. Okay. Now, ladies and gentlemen, in the event you didn't understand some of the things I was doing there, please do contact me. Visit me on my website, www.mvtutors.co.za. Book a free consultation, and I'll be glad to assist you. Alternatively, you can WhatsApp me on 076 and I'll be there to help. Otherwise, just like and subscribe this video so that more people can benefit from this content. Thank you so much.
Good, yeah. Hello everyone and welcome to MV Tutors. I'm Tsolo and I'll be looking at the probability questions of the Gauteng prelim that was just recently written. Okay, so I'm going to look at question 10 and question 11. And yeah, let's get right to it and see what it wants from us. But generally speaking, guys, how was the exam? Was it better? Was it good? Was it bad? I asked one of our students and she said she couldn't finish. So let's see, what did they ask you guys? All right, so question 10. So events A, B, and C occur as follows, where A and B are independent events. Okay, So we have the probability of A, probability of B, probability of A and B, and then the probability of C. So if I were to, just look at this, the fact that they told us that they're independent events, I'm already thinking about the product rule, okay? So it means then the probability, let me just adjust, the probability of A and B is equal to the probability of A times the probability of B. I mean, that is the product rule, right? Meaning that if I were to have events A and B, okay, let me not even go there. Let's just see what are they looking for. Okay, so 10.1, are A and B mutually exclusive events? So what are mutually exclusive events? They are events that happen at separate times, okay? There is no intersection between them. Okay, so basically, if I were to have the probability of A and B for mutually exclusive events, then I would have 0, okay? Because there is no intersection. They don't happen at the same time, okay? So, but if they were non-mutually exclusive, then events A and B would be that, okay? So basically you would have an intersection, okay? Whereas here, where they are mutually exclusive, they're just happening, okay? And there is no intersection. So let us see, are A and B mutually exclusive? So basically, if they are mutually exclusive, then probability of A and B, which is 0,1596, should be equal to the probability of A times B. So we're going to check. Okay, let's just move this to the bottom so that we can calculate. Okay, so they are telling us that probability of A and B is 0,1596. Now we need to check, okay, are we going to get the same answer on the right hand side? So probability of A is 0,38. Probability of B is 0,42. Now I need to check, if I multiply these two, what will I get? Okay, so let us see. Alrighty. Okay, so I have 0,38 multiplied by 0,42. And there we have it, 0,1596. So yes, they are equal. Okay, so now let's answer the question. They asked, are A and B mutually exclusive events? No, they are not. And then motivate your answer. They are not, because if I take the probability of A and multiply it by the probability of B, I do not get 0. I get 0,1596. Okay, so yeah, so there is an intersection of events. I don't know if that's a nice reason to give, that there's an intersection of events. Okay, alrighty. Yo, my voice sounds a little deep. I actually woke up early in the morning to record this. It's actually Saturday. The matrix wrote this paper yesterday on Friday. But yeah, so that was 10.1. Now, 10.2. By using the appropriate formula, show that the value of the probability of A or B is equal to 0,64. Okay, now that we know that that the event A and B are not mutually exclusive, whenever we use this formula, probability of A or B, okay, so we take the probability of A and we add it to the probability of B, and then we subtract the intersection, okay, so we say minus probability of A and B, okay, So we have the probability of A, it is 0.38, and the probability of B is 0.42, and then minus the intersection, which is 0.1596. So if it were mutually exclusive, you were just going to say probability of A plus probability of B. Okay, but it's not, and we're using this formula. So as we're doing this sum, we better get 0.64, okay? So 0.38 plus 0.42 minus 0.1596. And there we get it, okay, 0.64. I'm going to round it off to 2 decimal places, okay, 0.64. So we have shown it, okay. Righty, and then 10.3, calculate the number of people in the sample space. Okay, so there is a formula for that, okay, if you look at your paper. Yeah, where is that formula? Oh yeah, here it is. So if you check out this formula here, the probability of A is equal to the number of what? People in A and the number of the sample space. So I'm just going to rewrite this formula here. So probability of A is equal to that and that. Okay, let us go back to the question. Okay, so now it says calculate the number of people in the sample space. It would have been nice if they at least told us how many people are part of probability A, events A rather, or they could have told us in events B or something, but they didn't give us any number. All we have is the probability of the events occurring, okay? So yeah, that was a little bit of a tricky one. Okay, but in an exam situation, I'm just trying to see how many marks. Okay, it's 2 marks. Such little marks. So it is 2 marks, but in such a case, if they don't tell you anything about the number of people in any event, you can safely assume a number. Okay, so I know the probability. Okay, so I'm looking for the number of people in the sample space. So let me make NS the subject of my formula. Okay, so I have number of people in event A over the probability of A. So I know the probability of A is 0.38. Okay, for the number of people in event A, you can just guess a number, really. Okay, and whatever number that you eventually guess, yeah, you can just say, assuming that in event A there are so many people, I believe they should give you marks. So I'm looking at the probability of A and it's 0.38, and I want to work with numbers that are nice. So I'm going to assume that there are 380 people in event A. Okay, and if I do that, then the number of people in the sample space, okay, it'll be 380 divided by 0.38. It is 1,000 people. Okay, so you can then say, assuming that the number of people in event A are 380, my sample space is 1,000, and that's a nice round number to work with. But you could have chosen any number, okay, because they didn't give us anything in terms of numbers. Okay, so we have the number of people in the sample space, and then the last question. Okay, so determine that. So now whenever we have that little apostrophe there, it means not. Okay, so before I even answer this, I'm going to calculate the probability that C did not occur. And for me to do that, remember there's a complementary rule. Okay, so the probability that C didn't happen plus the probability of C should give me 1, and that is the complementary rule. Okay, so probability of C not happening is actually 1 minus the probability of C. And they gave us the probability of C, which is 0.28. Okay, so 1 minus 0.28, that will give us 0.72. Yeah, we're playing dangerously here, not using the calculator. But yes, it's 0.72. Okay, so now that we have that, we can then calculate the number of C event not happening. Oh, yeah, the number of C not happening. Okay, so how are we going to do that? Okay, so therefore, those number of people there, you're simply going to take your probability and you're going to, now 0.78, and we're going to multiply it by our sample space. Okay, and in that case, I think you're going to get 720 people. Okay, so yeah, I'm just going to say people. Okay, even they, people. Alrighty, so that was question 10. I think it wasn't so bad. Probably 10.3 was a little bit tricky because you're thinking, I don't have enough information. How am I going to answer it? But in such a case, guys, you make assumptions. If not sure, make assumptions and state those assumptions so that you can guide the marker, okay? They can't just wonder, what is this 380? Where is it coming from? State the assumption, assuming that there are 380 people in event A. The sample size is 1,000 people. Okay, now question 11. Okay, I think I'm going to pause and then take question 11 separately. All right, hello everyone. Okay, so we are going at it. Question 11, the last question of this paper. Let us see what they have for us. Okay, so they're saying each of the digits, we have 1, 1, 2, 3, 4, and 7. Okay, so we have 6 digits. Okay, so each of the digits is written on a separate card. The cards are then placed next to each other to create a 6-digit number. Okay, so now the question is, how many numbers start and end with the same digit? Okay, so I have 6 places available for this digit. Ooh, my lines. Can I start again? Okay, so I have 1, 2, 3, 4, 5, 6. Okay, much better. Alrighty, and then how many numbers start and end with the same digits? Same digit. Okay, so if you are assuming that these numbers are actually identical, okay, I'm gonna go forward assuming that the numbers are identical. Okay, so let me state my assumption. Okay, so assumption. Okay, numbers are identical. Okay, so yeah, that is my assumption. So if they are identical, okay, it means then for the first digit, okay, do you see I have 1, 1, 2, 3, 4, 7. And if they start and end with the same digit, it means I'm using up this one and I'm using up that one. So I'm going to have 1 here and I'm also going to have 1 here. Okay, so meaning I only have one option to put there. Okay, and I only have one option to put there. Then I'm left with 4 numbers. Okay, I know the counting principle can be a little tricky, but I hope you are with me. Okay, so I've already used up the ones, okay, because it has to start and end with the same number. Now I'm left with 4 options, okay. So on the second one here, I can put any of these 4. I can put the 2, the 3, the 4, or the 7. I can put any of them, okay. So there are 4 options for me to put there. Once I've put those 4 options, now I'm left with 3 options, okay. And once I have put the second one here, sorry, so I have 3 options for this third digit, okay. Then I'm left with 2, okay. So here I have 2 options, okay. So let's say for the second digit I used 2. It means for this here I only have 3, 4, 7. So I have 3 options available. If I use up 7, then for this one here, I only have 3 and 4 left. So I have 2 options. If I use up 4, then here I have 3 left. Okay, I hope you get me. So I only have 1 option left over here. Okay, I really hope you are with me and I didn't lose you anyway. But that's how I would tackle this problem. Okay, and then I would just multiply there at the end. And if I do that, I have 4 times 3, which is 12, and 12 times 2, which is 24. Okay, had I assumed that these numbers are not identical, that these numbers are actually different, then you would calculate it in a different way. Okay, how would you calculate it in that different way? Well, you would have, okay, yeah. If you were to assume that the numbers are different, okay, you still have 6 options available to you. Okay, I'm not gonna draw it out nicely. It's gonna take time. Okay, or maybe I should. All right, so you have 1, 2, 3, 4, 5, 6 available spots. Okay, so if the numbers are different, then you can have whatever you have here, right? On the first one and the last one, you know that they have to be the same. And then you have these 4 spots available to you. So then you would say, okay, then you would say here you have 4 factorial, okay, multiplied by these 2 here, 2 factorial. So basically, the reason why I say 2 factorial is because I have 2 options available to me. So one could be this side and that side, and you could swap it. Doesn't make sense, but you can swap it. So you have one this side and one that side. So that's why you multiply by the 2 factorial. And then in that case, 4 factorial should be 24, but let us check. So 4 factorial is 24 multiplied by 2 factorial, and that is 48. Okay, and that is how you would solve it. But going forward, guys, my main assumption is that these numbers are identical. So my answers are going to follow that. I was just showing you that if you assume that the numbers are different, you would calculate it differently. And they would accept both answers because they didn't really say what we should go with. Okay. So 11.1.2, find the probability that the numbers is 112347 or 743211. Okay, so how are we going to do that? Finding the probability. Well, firstly, I would like to find out, remember when you calculate the probability of something, okay, so if we're going to calculate the probability of it being 112347 or 743211. Okay, so we're gonna have these 2 events. Okay, let me not say 2 events. Let me just say you can either have this number 112347 or you could have 743211. So you can either have these 2 options, okay, over a certain number, and this indicates all the options that you could get. Okay, so we need to calculate that one. What are all the options that I could get? Okay, so remember the numbers that we have. Okay, we have 1, 1, 2, 3, 4, 7. Okay, and we have assumed that the numbers are identical. So if I were to get all possible options, okay, I would say then x is equal to, okay, remember that equation where you have n factorial, okay, over if you have any repetitions, so any number repeating itself, because we assumed it's identical, you would then write it here, m1 factorial. If there's another number that's repeating itself, m2 factorial. There's another number repeating itself, m3 factorial. And it would go that way. Okay. So now we only have one number repeating itself, which is 1. Okay. So therefore, n factorial just says how many numbers do you have available. We have 6 numbers available, so 6 factorial. And then we have 2 numbers actually that are repeating. So 1 occurs twice. Okay, and that is why we're dividing by 2 factorial. And then let us calculate what that value will be. So you have 6. No, what did I do? Okay, let's start again. We have 6. Geez, why do I use the sound? Okay, 6 factorial, there we go, over 2 factorial. Okay, and that answer would be 360. So the possible events are 360. So again, looking at our sum, because they asked for the probability that these two numbers would actually, find the probability that the number is 11, 23, 47 or 74, 32, 11. Okay, so let us do that. So we have 2 over there over x, and we found that x is 360. Alrighty, so then the probability is 2 over 360. 2 over 360 is actually what? 1 over 180. Okay, and yeah, if you really wanted to write it like this, you could have said 0, if I'm rounding it off to 2 decimal places, it would be 0,01. Okay, yeah. And then what are we doing now? Okay, 11.2. Okay, we are almost there, guys. Thank you for being patient and tuning in. I hope you are learning something. And please, guys, don't forget to like our videos and subscribe to our channel. Okay. So now 11.2 says n people numbered 1, 2, 3, 4, 5, 6, 7, until n are arranged randomly in a line. Find the number of ways in terms of n that person 1 and person 2 are standing next to each other. Okay, I looked at this question and I thought, let me do an example with you guys first, and then we'll answer the question. Because like I said, the counting principle can be a little bit tricky. So let's say I have 7 people, okay, that I want to place or put in chairs. So I have 1, 2, 3, 4, 5, 6, 7, okay. And in doing such, I have this couple, okay, that no matter what, they need to sit together. Okay, so this couple needs to sit together. So I have a boy and a girl, and they are sitting together, and the rest are sitting randomly. So I'm just going to put dots. If I were to determine the number of ways in which they could arrange themselves in these 7 chairs, okay, while making sure that that couple is always together, what I would do, I would take this couple as 1, okay? I have 1, I have 2, 3, 4, 5, 6. So basically I have 6 factorial. Okay, but do you realize within the couple, either the boy can sit on the left or the girl can sit on the left. So both of them can sit both sides. So I also need to multiply by 2 factorial, okay? And basically that's how I would determine it. So basically, if you look at this, you had 7 chairs, okay? But I had to subtract 1. And that's why I have the 6 factorial. And then I have to multiply by 2. Okay, so we're going to use that very same concept with this sum. So there are n people arranged, there are n people arranged randomly in a line. Okay, now we need to find the number of ways in terms of n that person 1 and person 2 are standing next to each other. Okay, so here it was fine. I had 7 people. Okay, but in this case, I have n amount of people. I don't know how many people there are, and hence we're using n. Okay, so we're gonna take n, and like we did there, subtract 1 and let it be a factorial. Why are we subtracting 1? Because we're taking that group, those 2 people that are standing next to each other, as 1. Okay, otherwise if they could be arranged anyway, the answer would just be n factorial. Okay, so we are taking n minus 1 factorial, and because we have those 2 people that must always stand together in a line, stand next to each other, we don't know is that one person gonna stand in front or behind the other. Okay, so we have 2 options available. Okay, and yeah, that is the number of ways. Okay, so if I were to write it out a little bit better, I would say 2 factorial times n minus 1 factorial. Okay, and that was how many marks? 3 marks. Okay, guys, we are done. The whole paper is done. I hope you guys enjoyed watching it and you learned something. The sun is rising. I can see the brightness this side. But yeah, thank you for tuning in. Please don't forget to like our videos, subscribe to our channel. Please share this information with your friends, especially those who are in Gauteng and have written the paper and are wondering how did they do. Remember, prelims are just preparation for the final exam. So if you can just look at the paper, see where you went wrong or where you went right and rejoice. But see where you went wrong, go over it, evaluate yourself, and make sure you do not repeat the same mistakes. Okay, that will help. All right. So yeah, enjoy the rest of your day or night, whatever time you're watching this. Thank you.